Very good evening.
Thank you. Thank you. Okay. So in previous classes, we discussed regarding shear force and bending moment diagram. And also in this particular class, let me move on to the very, very important concepts as per your exam point of view, that is strain energy. So in this particular topic, with respect to your syllabi, you are having strain energy. What is the strain energy stored in different kinds of structure, that is beams, frames, trusses, and also you have to evaluate the energy stored in those elements subjected to external loads. So this is very, very important topic as per structural engineering point of view. And also here you are going to study two more methods of strain energy. In strain energy, you are having various methods. The first very, very important method is Castigliano's theorem. And also in the particularly with respect to the Castigliano theorems, we have to solve the dummy load method also. They are included in your syllabi. So totally in strain energy part, you may expect it to get 3 to 4 questions because they have put in like two in the strain energy part as a 2 sections. So that's why in this particular class, we will discuss regarding the basics, how to arrive the equation of strain energy for various elements like beams, frames, and trusses. Generally, what they will do, they will ask a direct question like, what is the strain energy stored in the truss element? What is the strain energy stored in the beam element subjected to point load? So if the strain energy, that is the energy stored because of, we know that there is not a single load case. Load case, we are having different load cases. It may be a point load or it may be a uniformly distributed load. There are several kinds of loads, and also different types of beams. With respect to type of loading, with respect to different types of loads, we are getting different strain energy equations as well as different strain energy values. Generally, that what is mean by strain energy? The first thing is, what is mean by strain energy? Any idea? What is mean by strain energy? Students, am I audible? Please try to answer. What is mean by strain energy? Strain energy. There are two words. One is strain, another one is energy. I'm asking define strain energy. What is mean by strain energy? What is mean by strain?
Energy stored in a body due to strain of the material.
Yes, energy stored in the body due to the strain of the material or due to the deformation of the material. See, strain is nothing but it is a deformation. So this energy, this particular energy, that is the energy stored inside the material, in account of strain, it will come into picture. When strain will happen? When strain will happen? When strain will occur?
When there is a applied load on the member.
When there is a applied load on an element, it is subjected to deformation. The deformation is nothing but strain. So on that time, what happens? Whatever the stored energy is acts into picture, comes into picture. That particular concept now you have to study. So what are the fundamental things involved in this kind of energy? See, that is, what are the phenomena involved? One is we are applying external thing. So that is called work done. That is called work done. So because of that work done, what is happening inside the material? Right? So there are two aspects comes into picture. One is we are applying the external force. Because of that external force, there is a deformation. Because of that deformation, the energy dissipation will occur. That is called strain energy. That is called strain energy. That is the energy stored inside the member. When on account of deformations, it comes into picture. On account of deformation, this particular energy comes into picture. Okay. Now, basically, we are getting general strain energy equations. How we are getting general strain energy equations? We have to equate two things. One is deformation, and another one is what is the energy stored inside the material. So if you equate to whatever energy stored inside the body with respect to applied force or deformation, we are getting the equation. So let's see what are the different possible equations. Okay. So now tell me if the body is subjected to axial force. Let us say axial force. So axial force means which type of structure? Axial force. If say I'm telling that strain energy due to axial force. Say the first thing, once we know what is meant by strain energy, then I'm moving to the different forums. Okay. So now the first one is strain energy due to axial force. What is meant by axial force? What is meant by axial force?
Concentrated load.
Concentrated load. Any other answers? What is meant by axial force?
Perpendicular to the
Yes.
cross section.
Yes. Any other answers? See, axial force means, say this is a member. If this is a member, we are applying the load on the axis. Okay. Say it may be compressive. It may be compressive, or it may be, see, ಇದನ್ನ ನೀವು ಪಿನ್ ಟು ಪಿನ್ ವರ್ಡಿಂಗ್ ಸರಿಯಾಗಿ ಗೊತ್ತಿರಬೇಕು, ಇಲ್ಲ ಅಂದ್ರೆ ತುಂಬಾ ಕಷ್ಟಪಟ್ಟಾಗ್ಬಿಡ್ತೀರಾ ನೀವು. Okay, this is which kind of nature? This is tensile and this is compressive. See, I shown horizontal. Similarly, what about vertical axis? That is vertical axial. This is a vertical axis. So here also there are two possibilities. This is tension and also this is compression. See, these are the axial forces. So these kinds of forces, in which type of structures we can expect it? Any answers? These kinds of forces, in which type of structures we can expect it? Yes, any answers?
Determinate structures.
Determinate structures. Others, any answers? See, I will give a clue. I am asking about different types of structural elements. What are different types of structural elements?
In beams,
Beams,
columns,
columns, only beams and columns, frames,
frames,
trusses, right? So these kinds of forces, only these kind of forces where we are expected. My question is direct question. Only axial type of force, in which type of structures we can expect? The four option is beams, frames, columns, trusses.
trusses,
Trusses. Why? Because
there is
truss
no shear
is
force.
hinge jointed structure. What is meant by pin joint? What is hinge? There is no translation.
Yes.
Hinge will allow only what? Hinge will resist only reaction, translations. Hinge will allow rotation, but it will resist only translation. Translation means what? Only axial forces. Only axial forces. So these kind of forces, in which kind of structure? Only axial force. Which type of structure? That is
Truss.
trusses. It is trusses. Trusses. These are all pin jointed. Here you are having either tensile force, you are having either tensile force or which kind of forces? Only forces we are getting. There is no moment.
Compression
Right?
force.
Nature of the force, compressive or tensile. Madidiralla, method of joints, method of section. Madidiral one draw. Example, trusses. So the only axial type of forces we can expect it in trusses. So now, whatever I am going to derive the equation, strain energy due to axial force, where we can apply? In which type of structure we can apply?
Trusses.
Trusses. So ಅದನ್ನ ನೆನ್ಪಿಟ್ಕೋಬೇಕು. ಅಲ್ಲಿ ನಿಮ್ಗೆ strain energy due to axial force ಅಂತಾನೆ, ಟ್ರಸ್ ಅಂತ ಹೇಳಲ್ಲ. ಅರ್ಥ ಆಯ್ತಾ? ಡ್ಯೂ ಟು ಆಕ್ಸಿಯಲ್ ಫೋರ್ಸ್ ಅಂತ ಹೇಳ್ತಾನೆ ಅಷ್ಟೇ. ಟ್ರಸ್ ಅಂತ ಅವನು ಎಲ್ಲೂ ಹೇಳಕ್ ಬರಲ್ಲ. ಓಕೆ, ನೌ ಇಟ್ಸ್ ವೆರಿ ಈಸಿ ಟು ಡಿಟರ್ಮೈನ್. I will consider a bar element. Truss is a bar element. So I am going to consider a bar element, one bar element. This particular bar element subjected to axial pull. Subjected to axial pull. Subjected to axial pull, say F. What happens if F I am applying, one end is fixed, I am applying F on other side? What happens? What happens?
Deformation.
It will deform, or it will subject it to displacement. Say this is the displacement. So say this is delta. This is delta, and this member is having length A and E. This member is having L, length A and E. Now what is delta? You know that. What is delta? What is delta? Delta equals what? What is the equation?
PL over AE.
Yes, PL over AE. With respect to this case, FL over
FL by AE.
FL over AE. Say equation number 1. Now, if you take these quantities, if you see this L, A and E, this is constant. L is same, area is same, Young's modulus is same, this is constant. Therefore, what happens if I take a constant of proportionality? It will become delta proportional to F. Delta proportional to F. What it implies? If you plot a graph, delta versus F, the graph is linear. Delta versus F, the graph is linear, and it is, say this is delta. If I am representing x and y axis, this is force. So this, whatever, this is force F, as well as this is x axis is delta. This is a proportionality because of linear. This is linear. Now say this is O, this is A. So this is the deformation, whatever the graph here to here, this is the deformation, delta. So as per our definition, what is definition of strain energy? What is definition of strain energy? This is the
Stored in the material of deformation.
area. That's the deformation. That's the area. Strain energy is the defined as, this is the area under deformation. It's the area under deformation. So this is the area. So now strain energy, I can write directly U equal, what is the area of this particular element? OA. What is the area for this portion? Half into what is the height? This height is what? F. What is the delta? Deformation is
Delta.
Half F delta. Now you just substitute whatever the delta value. What is the delta value? U equal half into F into delta equals FL by AE. What is the value you are getting? U equals F square L by 2AE. F square L by 2AE. This is very, very important. This is the equation. Strain energy in any prismatic bar or in any prismatic member subjected to axial pull or axial force. What it implies? This equation, U equal F square L by 2AE. What is this? Strain energy
Due to axial force.
In prismatic members. This is very, very important. Please take a note. Or sometime they will ask a question like, what is the strain energy stored in truss element? Truss, a bar element. They are not asking like truss. bar element. What is the answer? What is the answer? They will give different answer like f square L by 3AE, f square L by 4AE, f square L by 2AE and all. So now on that case, you have to pick, this is the axial force due to bar element. Bar element. Any doubts? Any doubts?
No, sir.
Now see, I am expressing this equation in terms of F. Now I want, sometimes they will give a solution in terms of delta. In terms of delta ಕೊಟ್ಬಿಡ್ತಾನೆ. ಅವಾಗ ಏನ್ ಮಾಡ್ತೀರಾ ಅಂದ್ರೆ ಆನ್ಸರ್ ಅಲ್ಲಿ ಎಫ್ ಇರಲ್ಲ, ಇದೇನು ಎಫ್ ಸ್ಕ್ವೇರ್ ಎಲ್ ಬೈ 2AE ಈಸಿಯಾಗಿ ಮಾಡ್ಬಿಡ್ತೀರಾ. ಅವನು ಇನ್ ಟರ್ಮ್ಸ್ ಆಫ್ ಡೆಲ್ಟಾ ಕೊಡ್ತಾನೆ. ಡೆಲ್ಟಾ ಕೊಟ್ಟಾಗ ಏನ್ ಮಾಡ್ತೀರಾ? ಸೊ ಯು ನೋ ದಟ್ ಡೆಲ್ಟಾ ಈಕ್ವಲ್ಸ್ ಎಫ್ ಎಲ್ ಬೈ AE. What is F? What is F now? What is F? What is F? F equals
Delta
delta upon L.
AE over L. Now substitute here in the place of F square. Substitute this value. S ಬರುತ್ತೆ ಹೇಳಿ U equals. ನೀವೇ ಹೇಳಬೇಕು. Now I have given clue. To express in terms of delta. You have to consider this equation and take delta and take F and substitute this F square. Now what is the strain energy?
Sir, innocent ಹೇಳ್ತೀರಿ.
How much?
Delta only, sir. Delta by 2.
Delta by 2. Any other answers?
Delta AE by 2L.
Delta
AE by 2.
AE by 2L. Any other answers?
2L.
Delta square AE
Yes,
by 12.
very good.
Yes.
Delta square AE divided by 2L. See, ನಿಮಗೆ ಕ್ವಶನ್ ನಾಗೆ ಇದನ್ನು ಸಹ ಕೇಳಬಹುದು. This is also important. What it indicates? This is the another form of strain energy in terms of displacement only. You see here, there is no force, only displacement. They make a second question also. In ಕೆಲವು ಕ್ವಶನ್ ಆಗ ಬರೀ ಎಫ್ ಕೊಡ್ತಾನೆ, ಸ್ಟ್ರೈನ್ ಎನರ್ಜಿ ಫೈಂಡ್ ಔಟ್ ಮಾಡು ಅಂತ. ಇನ್ ಕೆಲವು ಕ್ವಶನ್ ಡಿಸ್ಪ್ಲೇಸ್ಮೆಂಟ್ ಕೊಡ್ತಾನೆ. ಏನ್ ಕೊಟ್ಟರು ನೀವು ಈಕ್ವೇಶನ್ ನ ಬರೀಬೇಕು. This is the, what is the form? This form. This is another form of strain energy and in terms of displacement only. This is in terms of displacement. In terms of displacement. See, please take a note. ಇದನ್ನ ನೋಟ್ ಮಾಡ್ಕೊಳ್ಳಿ. ನಾನು ಏನ್ ಪಾಠ ಮಾಡ್ತಾ ಇದ್ದೇನೆ ಅದನ್ನ ನೋಟ್ ಮಾಡ್ಕೊಳ್ಳಿ. ಬಿಕಾಸ್ ಯಾಕೆ ಅಂದ್ರೆ ನಿಮ್ಮ ಕ್ವಶನ್ ಪೇಪರ್ ನಲ್ಲಿ ಈ ತರ ಕ್ವಶನ್ಸ್ ಕೇಳಿದಾಗ ಮೋಸ್ಟ್ ಆಫ್ ದಿ ಕೇಸಸ್ ಸ್ಟೂಡೆಂಟ್ಸ್ಗೆ ಏನು ಅಂತಾನೆ ಗೊತ್ತಾಗಲ್ಲ. ಗೊತ್ತಾಯ್ತಾ? ನಾನು ಇದನ್ನೆಲ್ಲ ಈ ಎರಡು ಇಕ್ವೇಶನ್ ಹೇಳಿದ್ ಯಾವ್ದಕ್ಕೆ? an axial force or bar element. Sometimes this is also called as strain energy in bar element. Bar element ಅಂದ್ರೆ ಏನು? Yes, just like a trusses ಅಲ್ಲಿ ಬರುತ್ತಲ್ಲ ಎಲಿಮೆಂಟ್ಸ್ ಗಳನ್ನು ಬಾರ್ ಎಲಿಮೆಂಟ್ ಅಂತ ಕರೀತಾರೆ. ಗೊತ್ತಾಯ್ತಾ? Any doubts in these two equations? Any doubts? Students, are you getting whatever I am saying? Catch ಮಾಡ್ತಿದ್ದೀರಾ? Any doubts?
No, sir.
Okay. Next, this ಇದನ್ನ ಬರ್ಕೊಂಡ್ರಾ? Have you taken a note? What is the equation? Strain energy due to axial force. What is the strain energy due to axial force? Okay. Now I am writing for truss. Truss ನಲ್ಲಿ ನಿಮ್ಗೆ ಈ ತರ ಕೇಳಲ್ಲ. ಇದೆಲ್ಲ ಬಾರ್ ಎಲಿಮೆಂಟ್ ಆಯ್ತು. ಇವಾಗ ಟ್ರಸ್ಗೆ ಮಾಡ್ಬೇಕಾದ್ರೆ the same equation we are writing in terms like this. U equals, see, but in truss, see here, this is for one element, this is for single element. Whatever the equation we derived, this is for single element. But what happens? You see the truss here, there is several members. So different lengths. See, say this is L1, this is L2, right? I can apply here one force at joint At this joint, another force, that is F1, F2. So what are variables here? What are varying? What are varying? F is varying, L is varying, area and E are same. Always. This is also one of the important question in trust. Actually, what are the basic assumptions in trust analysis? You know that flexural rigidity is same, Young's modulus is same, area of member is same. So these are all assumptions. So as per this, what are the variables? What are the variables? What are the variables? I have shown a trust figure also. What are the variables? F and L. F and L. So the equation is written as sigma equal, that is U equals summation of I equals 1 to N, N numbers, 1 to N numbers. So it may be Fi square Li divided by 2 AE. This is same. Both are same. AEI. So this is the equation for, this is the equation strain energy. This is the strain energy equation for what? Truss structure. Equation for truss structure. See, ನಿಮಗೆ ಟ್ರಸ್ ಅಂತ ಕೇಳಿದ್ರೆ ಆಪ್ಷನ್ ನಲ್ಲಿ ಇದು ಇರುತ್ತೆ, ಆಪ್ಷನ್ ನಲ್ಲಿ ಇದು ಇರುತ್ತೆ. ಈ ಎರಡು ಆಪ್ಷನ್ ಅಲ್ಲಿ ಇರುತ್ತೆ, ಪ್ಲಸ್ ಇದನ್ನು ಕೊಡ್ತಾನೆ. ಅವಾಗ ನೀವು ಯಾವ್ದು ಪಿಕ್ ಮಾಡಬೇಕು? ವಾಟ್ ಇಸ್ ದ ಈಕ್ವೇಶನ್ ಫಾರ್ ಸ್ಟ್ರೈನ್ ಎನರ್ಜಿ ಸ್ಟೋರ್ಡ್ ಇನ್ ಟ್ರಸ್ ಎಲಿಮೆಂಟ್? ವಾಟ್ ಇಸ್ ದ ಈಕ್ವೇಶನ್? U equals sigma 1 to N Fi square Li 2 AEI. Any doubts? Any doubts? Any doubts? ಇದನ್ನ ನೋಡಿ ನೀವು ಈಸಿಯಾಗಿ ಬರಿಬಹುದಲ್ಲಪ್ಪ. ಇಲ್ಲಿ ಎಷ್ಟು ಮೆಂಬರ್ಸ್ ಇದೆ? ಸೊ ಸಮೇಷನ್ ಅಲ್ವಾ, ಎಲ್ಲದನ್ನು ಆಡ್ ಮಾಡ್ಬೇಕು ತಾನೆ ಟೋಟಲ್ ಸ್ಟ್ರೈನ್ ಎನರ್ಜಿಗೆ. ಸೊ ಸಮೇಷನ್ ಆಫ್, ದಟ್ಸ್ ವೈ 1 to N Fi square Li 2 AEI. So any doubts? Shall I move on to next thing? Second thing, strain energy due to flexure.
ಅದೇ ಇಂಪಾರ್ಟೆಂಟ್.
ಏನಪ್ಪ? ಅದೇ ಇಂಪಾರ್ಟೆಂಟಾ? ಇದು ಇಂಪಾರ್ಟೆಂಟ್. Strain energy due to flexure or bending. This is very, very important. ಇದನ್ನ ಯಾವ ಸ್ಟ್ರಕ್ಚರ್ ಅಲ್ಲಿ ಎಕ್ಸ್ಪೆಕ್ಟ್ ಮಾಡಬಹುದು? This kind of deformation
in beams.
Beams, only beams. Others, ಯಾರೋ ಒಬ್ರು ಇಬ್ರು ಹೇಳ್ತಾ ಇದೀರಾ, ಉಳಿದವರು ನೀವು ಅಟೆಂಪ್ಟ್ ಮಾಡ್ಬೇಕಪ್ಪ ಕಂಪಲ್ಸರಿನೋ. Others, only beams. Beams and frames, both are structural elements. ಗೊತ್ತಾಯ್ತಂಡ್ರೋ? beams and frames. See, ನಿಮ್ಗೆ ಇರೋದೇ ಎರಡು ಇಕ್ವೇಶನ್. ಈ ಇಕ್ವೇಶನ್ ಟ್ರಸ್ ಗೆ, ಇವಾಗ ಡಿರೈವ್ ಮಾಡೋ ಇಕ್ವೇಶನ್ beams and frames ಗೆ, ಎರಡಕ್ಕೂ ಹೋಲ್ಡ್ಸ್ ಆಗುತ್ತೆ. ಅರ್ಥ ಆಯ್ತಾ? ಓಕೆ, shall we start this? See, beam ನಲ್ಲಿ ಏನ್ ಮಾಡ್ತಾನೆ, ಒಂದು ಸಣ್ಣ ಸ್ಮಾಲ್ ಎಲಿಮೆಂಟಲ್ ಪಾರ್ಟ್ ತಗೊಳ್ತಾನೆ ಕರ್ವೇಚರ್ಗೆ. ಅಂದ್ರೆ ಡಿಫಾರ್ಮೇಶನ್ ಅಲ್ಲಿ ಬೆಂಡ್ ಆಗಿರ್ತಾನೆ ಬೀಮು. ಫ್ಲೆಕ್ಚರ್ ಅಂದ್ರೆ so this is the O and it is taking this as theta and this is radius R and this is L, that is length. So for this type of bending there may be applying moment M. Now what is theta? If you neglect curvature, consider as a triangle. What is theta value? What is theta? Opposite by adjacent. L by R. So what is the bending equation? Take equation 1. What is bending equation? M by I equals
I into E by R.
Very good. Ashte sako. M by I equals E by R. Now what is 1 over R? Now 1 over R equals 1 over r equals, you know that. What is, if you take theta for this equation, substitute here. So what we are getting in the place of 1 over r, we can substitute what? In the place of 1 over r, we can substitute m by ei here. So what we are getting? ml by ei. Say equation number 2. Just substitute this particular value to equation 1 in the place of 1 by r. This is theta equal 1 by r into L. So if you substitute here 1 by r, it will become ml by ei. Any doubts? Now you know that this is also similar. You know that here m is the moment, LEI is constant. Therefore, theta is proportional to m. Now plot a curve in a similar fashion. Plot a curve. So this is m. This is theta. You are getting linear variation. And this is the area. So this is OA. Now what is strain energy? U equals, what is U? Area under this part. That is half into m into theta. See, this is m and this is theta. Half into m into theta. Now you substitute the value of theta. What is theta? Substitute here. What is the value you are getting? U equals half into m into ml by ei. What is the final equation we are getting? U equals m square L by 2ei. This is the equation. Very, very important equation. This is the equation. Strain energy stored in what? Strain energy stored in beam element, not entire beam. Beam element. This is a one small element. See, we consider a small element. So don't confuse with MCQ questions. Sometimes they may ask beam element. If he asks for entire beam, what we have to do? Now this is the element. I require for entire beam. What I have to do? I know only one small part, but I require for entire section. What we have to do? We have to yen madbeko.
Add summation.
Integral. Don't confuse. Okay. Integral madre sigado gottalva, limits hakbeko. Area. Integral maddaga you are getting mx square into dx into L into dx divided by 2ei. This is the equation you have to remember for beam. This is the equation, strain energy for beam or frame element. Both are same. Frame element. See, one more thing you have to add. One more thing here, mx at different sections, x and li. You take li. Remaining things are same. And limit 0 to L. Now I require this equation in terms of displacement. How we are getting in terms of displacement? Now I require this equation in terms of displacement. How we are getting? That is also very simple one. See, this is also sometime they will ask in MCQ questions. U equals, you take 1 over 2ei outside, 1 over 2ei outside, and integral of, what is the moment? Moment is nothing but that is second order derivative, right? Slope is first order. Dy by dx is slope. Dy by dx is slope. D square y by dx square. This is the second order. This is the bending moment into d square L into dx, or you take L outside, no problem. L you take here, L into dx. So this is the equation for strain energy in framed structure or beam structure. Li, don't forget Li, because length is varying, right? Into dx, into dx in terms of pure displacement. This is in terms of displacement. In terms of displacement. Any doubts? See, please keep a note. These are the very, very important thing. They will ask direct MCQ. Direct agi idನ್ನ ಹಾಕಿರ್ತಾನೆ ನಿಮಗೆ ಅಲ್ಲಿ ಏನು ಅಂತಾನೆ ಗೊತ್ತಾಗಬಾರದು, ಆ ತರ ಅನಿಸ್ತಾ ಇರುತ್ತೆ ನಿಮಗೆ, ಗೊತ್ತಾಯ್ತಾ? So always keep in your mind there are few equations for general strain energy. See, this is not Castigliano's theorem. This is not your dummy load method. This is the general strain energy. General strain energy due to axial force. General strain energy due to flexure. General strain energy due to flexure. Clear? Any doubts? Any doubts? Okay, see. This is F square L by 2 AE. AE. Here, EI. Now I can ask a question. What is AE and what is EI?
EI is flexural rigidity.
EI is flexural rigidity. Very good. What is AE? Others, please attempt.
Modulus of rigidity. Rigidity
Okay,
modulus.
Others, try. See, why you told you it is flexural rigidity? Because
Axial
this is
rigidity,
under,
sir.
because
Axial
this is
rigidity.
under flexure. This is
Flexure.
under flexure. That's
Yes,
why
sir.
you told flexural rigidity. This is under what? This is under
Axial.
what?
Axial rigidity.
force.
This henceforth, this is which type of rigidity?
Axial rigidity.
Axial rigidity. See, ನಿಮ್ಗೆ ಗೊತ್ತಾಗಬೇಕು. AE is
Yes,
nothing but
sir.
axial rigidity. EI is nothing but flexural rigidity. ಇದನ್ನು ಕೇಳ್ಬಿಡ್ಬೋದು ನಿಮ್ಗೆ. ಎಲ್ಲ ತುಂಬಾ ಸಿಂಪಲ್ ಬೇಸಿಕ್ಸ್ ಅಲ್ಲಿ ಹೊಡಿತಾರೆ ಆರಾಮಾಗಿ ಕ್ವಶನ್ಸ್ ನ. ಅರ್ಥ ಆಯ್ತಾ? ವೇರ್ AE is ನಿಮ್ಗೆ ಏನ್ ಮಾಡ್ಬಿಡ್ತಾನೆ ಗೊತ್ತಾ? ನಿಮ್ಗೆ ಅರ್ಥನೇ ಆಗ್ಬಾರ್ದು. ಆಕ್ಸಿಯಲ್ ರಿಜಿಡಿಟಿ ಅಂದ್ಬಿಟ್ಟು ವ್ಯಾಲ್ಯೂ ಕೊಟ್ಬಿಡ್ತಾನೆ.
Yes, sir.
ಆಮೇಲೆ ಏರಿಯಾನು ಹಾಕ್ಬಿಟ್ಟಿರ್ತಾನೆ. ನಿಮ್ಗೆ ಏರಿಯಾನು ತಗೊಂಡು ಹೀಗೆ ಅದನ್ನೆಲ್ಲ ಹಾಕಿ ಏನೇನೋ ಆನ್ಸರ್ ಮಾಡ್ಬಿಡ್ತೀರಾ. ಆಕ್ಸಿಯಲ್ ರಿಜಿಡಿಟಿ ಇಟ್ಸ್ ಎ ಪ್ರಾಡಕ್ಟ್ ಆಫ್ ಎ ಅಂಡ್ ಇ. ಫ್ಲೆಕ್ಸುರಲ್ ರಿಜಿಡಿಟಿ ಇಸ್ ಎ ಪ್ರಾಡಕ್ಟ್ ಆಫ್ ಇ ಅಂಡ್ ಐ. ಅದು ನಿಮ್ಗೆ ಗೊತ್ತಾಗ್ಬೇಕು. ಕ್ಲಿಯರ್? ಎನಿ ಡೌಟ್ಸ್? ಎನಿ ಡೌಟ್ಸ್? ಓಕೆ, ಇವಾಗ ಒಂದು ಟೇಬಲ್ ಮಾಡಿ ನೆನ್ಪಿಟ್ಕೊಂಬಿಡಿ. ದಿಸ್ ಈಸ್ ಬಿಗ್ ಡ್ಯೂ ಟು ಓನ್ಲಿ ಸ್ಟ್ರೈನ್ ಎನರ್ಜಿ ಅಂತ. ಇದು ತುಂಬಾ ಇಂಪಾರ್ಟೆಂಟ್. ನನ್ಗೆ ನಿಮ್ಗೆ ಏನಂದ್ರೆ ಅರ್ಥ ಆದ್ರೆ ಮುಗೀತು, ನೀವು ಶೂರ್ ಆಗಿ ಮಾಡ್ತೀರಾ. ಸ್ಟ್ರೈನ್ ಎನರ್ಜಿ. ಸ್ಟ್ರೈನ್ ಎನರ್ಜಿಲಿ ಯಾವ ತರದಪ್ಪ ನೀವು ಮಾಡಿದ್ದು? ಫಸ್ಟ್ ಒನ್ ಇಸ್ axial force. Second one is flexure or bending. ಸರಿನಾ? ಸೊ ಇಲ್ಲಿ ಓಕೆ, ಇಲ್ಲಿ ನಿಮ್ಗೆ ಸ್ಟ್ರಕ್ಚರ್ಸ್, ವಿಚ್ ಕೈಂಡ್ ಆಫ್ ಸ್ಟ್ರಕ್ಚರ್ಸ್? ಆಕ್ಸಿಯಲ್ ಅಲ್ಲಿ ಯಾವ ಟೈಪ್ ಆಫ್ ಸ್ಟ್ರಕ್ಚರ್ಸ್ ಬರ್ಬೋದು? ಆಕ್ಸಿಯಲ್ ಅಲ್ಲಿ ಯಾವುದು?
Truss.
ಫ್ಲೆಕ್ಚರಲ್ ಅಲ್ಲಿ
Beams and frames.
beams and frames. Now general equation for section. ಈಗ ಬಾರ್ ಎಲಿಮೆಂಟ್ ಗೆ ಜನರಲ್ ಈಕ್ವೇಶನ್ ಏನು? ವಾಟ್ ಇಸ್ ದ ಜನರಲ್ ಈಕ್ವೇಶನ್? U equals, what is the general equation?
F square
F
P
square. What?
L by
Only F square.
2AE. F square L by 2AE.
F square by 2EI. Eಷ್ಟನಾ?
L, sir. F square L by 2AE.
F square L by 2EI. ಆಮೇಲೆ beams ಗೆ
2AE sir. AE sir. AE truss sir.
2AE, sir.
Correct. Okay. Two AE. F square L by 2AE. ಇಲ್ಲಿ M square ಹೇಳ್ರು
L by 2EI.
L by 2EI. For structure ಗಿಂತ ಮುಂಚೆ ಡಿಸ್ಪ್ಲೇಸ್ಮೆಂಟ್ ಬರೀರಿ, ಅದು ಫೋರ್ಸ್ ಆಯ್ತು. This is for force equation. Next, displacement equation. Here, what is displacement equation? So ನೀವು ಯಾರು ಬರ್ಕೊಂಡಿಲ್ಲ, ಸುಮ್ಮನೆ ನೋಡ್ತಾ ಇದ್ದೀರಾ. ನೋಡಿ ಯಾಕೆ 5 ನಿಮಿಷ ಬೇಕು? ಮತ್ತೆ ಎಲ್ಲ ಬರೆಯಕ್ಕಾಗತ್ತಾ?
Delta square AE by 2L.
Very good. Delta square AE by 2L. Ido. What is the displacement equation? Second order ಬೇಕು ಅಂದ್ರೆ U equals 1/2EI outside ತಗೊಳ್ತೀನಿ. Integral of
0
second
to L.
order B square Y by dx square L into dx. Pure displacement ಆಯ್ತು. Now if you want for structures ಬೇಕು ಅಂದ್ರೆ ಇದು ಟ್ರಸ್ಗೆ ಬೇಕು ಅಂದ್ರೆ ಏನಾಗುತ್ತೆ ಈಕ್ವೇಶನ್? ಟ್ರಸ್ ಬೇಕು ಅಂದ್ರೆ ಏನಾಗುತ್ತೆ? summation of I equal 1 to n fi square Li divided by 2AE into I. ಅದೇ ತರ ಇದು ಎಂಟೈರ್ ಸ್ಟ್ರಕ್ಚರ್ ಬೇಕು ಅಂದ್ರೆ ಏನಾಗುತ್ತೆ? ಇಂಟಿಗ್ರಲ್ ಆಫ್ mx square Li into dx divided by 2EI. ಕೆಲವು ಟೈಮ್ ಕೊಡ್ಬೇಕಾದ್ರೆ 1/2A ಔಟ್ಸೈಡ್ ಬೇಕಾದ್ರೂ ತಗೋಬಹುದು. ಸೊ ನಿಮ್ಗೆ ಸ್ಟ್ರೈನ್ ಎನರ್ಜಿ ಅಂದ್ರೆ ಜನರಲ್ ಸ್ಟ್ರೈನ್ ಎನರ್ಜಿ ಇಕ್ವೇಶನ್. ದಿಸ್ ಇಸ್ ಜನರಲ್ strain energy equation. This is for general strain energy equation. So any doubts? ಏನಾದ್ರು ಡೌಟ್ಸ್ ಇದ್ರೆ ಕೇಳಿ. ಈಗ ನೆಕ್ಸ್ಟ್ ಅಲ್ಲಿಗೆ MCQ ಹೋದಾಗ ನೀವು ಕನ್ಫ್ಯೂಷನ್ ಆಗಬಾರ್ದು. ಸ್ಟೂಡೆಂಟ್ಸ್ ಎನಿ ಡೌಟ್ಸ್? ಏನಿಲ್ವಾ? ಬರ್ಕೊಂಡ್ರಾ? Okay, shall I move on to some of the few MCQ topics? ಇದ್ರ ಮೇಲೆ ಏನ್ ಬರುತ್ತೆ ಅದು ಮಾಡ್ಬಿಟ್ಟು ಕ್ಯಾಸ್ಟಿಗ್ಲಿಯಾನೋಸ್ ಬರೋಣ. ಕ್ಲಿಯರ್? ಎನಿ ಡೌಟ್ಸ್? ದಿಸ್ ಇಸ್ ದ ಬೇಸಿಕ್ ಆಫ್ ಸ್ಟ್ರೈನ್ ಎನರ್ಜಿ. ಇಷ್ಟೇ. ಇದು ನೆಕ್ಸ್ಟ್ ಟಾಪಿಕ್ ನಿಮ್ಗೆ ಇರೋದು ಕ್ಯಾಸ್ಟಿಗ್ಲಿಯಾನೋಸ್. ಅದು ಸ್ಟ್ರೈನ್ ಎನರ್ಜಿ ಅಂದ್ರೆ ಇಷ್ಟೇ ಇರೋದು ನಿಮ್ಗೆ. ಏನಾದ್ರು ಡೌಟ್ ಇದೆಯಾ? ಇಷ್ಟೇ ಇರೋದು ಸ್ಟ್ರೈನ್ ಎನರ್ಜಿ ಅಂದ್ರೆ, ಜನರಲ್ ಸ್ಟ್ರೈನ್ ಎನರ್ಜಿ ಇಷ್ಟೇ. ಇದೇ ಒಂದು ಟಾಪಿಕ್ ನಿಮ್ಗೆ. ಇದರ ನೆಕ್ಸ್ಟ್ ಟಾಪಿಕ್ ನಲ್ಲಿ ನಿಮ್ಗೆ ಕ್ಯಾಸ್ಟಿಗ್ಲಿಯಾನೋಸ್ ಥಿಯರಮ್ ಹಾಕಿದ್ದಾರೆ. Clear? Any doubts? Okay. Now I will move on to some presentation part. See, what is mean by strain energy? So generally, strain energy is the stored energy inside the body associated with deformation of the member. We have already discussed regarding this, right? This is the deformation of the member. See, this is very, very important. Deformation is associated with deformation of the member. And also this is very, very important term. When an elastic body, see, that's why I have shown linear lines. ನೀವು ನೋಡಿದ್ರಲ್ಲ ಆ ಸ್ಟ್ರೆಸ್, ಆ ಗ್ರಾಫ್, ಲೋಡ್ ವರ್ಸಸ್ ಡಿಫ್ಲೆಕ್ಷನ್ ಗ್ರಾಫ್, ಬರೀ ನಾನು ಲೀನಿಯರ್ ತಗೊಂಡೆ. ಅಂದ್ರೆ ನೀವು ಪ್ರಾಕ್ಟಿಕಲ್ ಆಗಿ ಅರ್ಥ ಮಾಡ್ಕೊಳಕ್ ಟ್ರೈ ಮಾಡಿ. ಸ್ಟ್ರೈನ್ ಎನರ್ಜಿ ರಿಟೈನ್ ಒರಿಜಿನಲ್ ಶೇಪ್ ಬರಕ್ ಚಾನ್ಸ್ ಇರೋದು ಯಾವ ಸ್ಟೇಟ್ ನಲ್ಲಿ? ಓನ್ಲಿ ಆನ್ ಎಲಾಸ್ಟಿಕ್ ಸ್ಟೇಟ್. ಆ ಎನರ್ಜಿ ಫೈಟ್ ಮಾಡುತ್ತೆ, ಬ್ರಿಂಗ್ ಬ್ಯಾಕ್ ಕಮ್ಸ್ ಇನ್ ಟು ಒರಿಜಿನಲ್ ಪೊಸಿಷನ್. ನೀವು ಮೈಲ್ಡ್ ಸ್ಟೀಲ್ ನೀವು ಟೆಸ್ಟಿಂಗ್ ಮಾಡಿದಾಗ ವೆನ್ ಯು ಆರ್ ಡೂಯಿಂಗ್ ಟೆಸ್ಟಿಂಗ್ ಎ ಸ್ಪೆಸಿಮನ್, ಮೈಲ್ಡ್ ಸ್ಟೀಲ್ ಸ್ಪೆಸಿಮನ್ ಇನ್ ಲ್ಯಾಬೊರೇಟರಿ ಕಂಡೀಷನ್ಸ್, in initial stage of loading, what happens? When you apply load, it will get deformed. At some time, because of energy, it comes to its original position. So that's why we have taken an elastic. This is very, very important. Loaded in elastic limit, it deforms, and some work is done, which is stored within the body. See, that is strain energy. So that whatever the power or whatever the particular energy stored inside a body, when it is in elastic limit, it comes into picture. That particular energy is called strain energy. This stored energy is strain energy. See, ನಿಮಗೆ ಇದನ್ನ MCQ ನಲ್ಲಿ ಡೈರೆಕ್ಟ್ ಆಗಿ ಎತ್ತಾಕ್ಬೋದು. ಹೆಂಗ್ ಕೇಳ್ಬೋದು ಅವನು? ಎನರ್ಜಿ, what is the strain energy? So energy stored within elastic limit, energy stored in yield or elastoplastic limit, energy stored in deformation limit, or energy stored in plastic deformation limit anta. So which one you have to pick?
Energy stored in deformation.
Not deformation. See, why you are getting the thing is direct deformation ಯಾಕೆ ಹೋಗ್ತೀರಾ? elastic deformation.
Sir, elastic deformation.
ಬರೀ deformation ಅಂದ್ರೆ ಲಾಸ್ಟ್ ಪ್ಲಾಸ್ಟಿಕ್ ಸ್ಟೇಜ್ ಅದು.
Okay, okay sir.
ಗೊತ್ತಾಯ್ತಾ? ಎಲಾಸ್ಟಿಕ್, ಅದಕ್ಕೆ ನಿಮ್ಗೆ ನಾವು ಯಾವ ತರ ಗ್ರಾಫ್ ತಗೊಂಡ್ವಿ ಏರಿಯಾಗೆ ಇಷ್ಟೇ. ಅಂದ್ರೆ ಏನಿದು? ದಿಸ್ ಇಸ್ ದ ಎಲಾಸ್ಟಿಕ್ ಗ್ರಾಫ್. ದಟ್ಸ್ ವೈ ಏರಿಯಾ ನಿಮ್ಗೆ ಹಾಫ್ ಇಂಟು ಬೇಸ್ ಇಂಟು ಹೈಟ್ ಬರ್ತಾ ಇದ್ದಿದ್ದು.
Sir, resilience ಅಂದ್ರೆ ಏನು ಸರ್?
Resilience also this is the same. This is the, yes, very good question. It's nothing but your energy, strain energy is resilience. That is also area under elastic curve. Toughness ಅಂದ್ರೆ ಬೇರೆ, ಫುಲ್ ಅದು ಫ್ರಾಕ್ಚರ್ ವರ್ಗುವೆ.
Okay.
ನೀನ್ ಕೇಳಿದ್ಯಲ್ಲ ಈಗ ಹಾಕಿದ್ಯಲ್ಲ, ಅದನ್ನು ಹಾಕ್ಬೋದು MCQ ನಲ್ಲಿ. Strain energy is proportional, whatever the energy is equivalent to resilience, fracture. ಏನ್ ಬೇಕಾದ್ರೂ ಕೇಳ್ಬೋದು. ನಿಮಗೆ ಕಾನ್ಸೆಪ್ಟ್ ಕರೆಕ್ಟ್ ಆಗಿ ಗೊತ್ತಿರ್ಬೇಕು. ನೋಡು, ನಿಮ್ಗೆ ಇದು ಕರೆಕ್ಟ್ ಆಗಿ ರೆಸಿಲೆನ್ಸ್ ಅಂತ ಹೆಂಗ್ ತಲೆಗೆ ಬಂತು? ಬಿಕಾಸ್ ಎಲಾಸ್ಟಿಕ್ ಅಲ್ಲಿ ಅಲ್ಲಿ ಹೇಳಿದ್ವಿ, ಸರಿನಾ?
Okay sir.
ಸೇಮ್, ವೆರಿ ಗುಡ್, ಇಟ್ಸ್ ದ ಆನ್ಸರ್. ಓಕೆ, ಇದೇ ಬೇಕಾಗಿರೋ, ಇದು ಇಂಟರಾಕ್ಟ್ ಮಾಡ್ಬೇಕು, ಇಲ್ಲಾಂದ್ರೆ ಗೊತ್ತಾಗಲ್ಲ ನಿಮ್ಗೆ. ಓಕೆ, ಸಿ, ಇಟ್ ಈಸ್ recoverable without loss as soon as load is removed. See, this is very, very important. Strain energy is which type of energy? Strain energy is permanent, or strain energy is recoverable?
Recoverable.
Strain energy is dissipating? None of this. This
recoverable
is the question they may set. So on which you have to pick recoverable. Strain energy is recoverable energy. See, ಜಸ್ಟ್ ಒಂದೊಂದು ಪಾಯಿಂಟ್ ನಲ್ಲೇ ಸೆಟ್ ಮಾಡ್ಬೋದು ಬೇಸಿಕ್ಸ್ ನ ನಿಮ್ಗೆ, ಗೊತ್ತಾಯ್ತಾ? ಬಟ್ ಇಫ್ ಎಲಾಸ್ಟಿಕ್ ಲಿಮಿಟ್ ಎಕ್ಸೀಡ್ಸ್, ಪರ್ಮನೆಂಟ್ ಡಿಫಾರ್ಮೇಶನ್ ಅಕರ್ಸ್ ಅಂಡ್ ಪಾರ್ಟಿಕಲ್ಸ್ ಆಫ್ ಮೆಟೀರಿಯಲ್ಸ್ ಆಫ್ ಬಾಡಿ ಸ್ಲೈಡ್ ಒನ್ ಓವರ್ ದಿ ಅದರ್, ಅಂದ್ರೆ ಫೇಲ್ಯೂರ್ ಆಗೋಯ್ತು ಅಂತ, ಅಲ್ಲಿಗೆ ಏನ್ ನಿಮ್ಗೆ ಸ್ಟ್ರೈನ್ ಎನರ್ಜಿ ಬರಲ್ಲ. ಸ್ಟ್ರೈನ್ ಎನರ್ಜಿ ಇಸ್ ಆಲ್ವೇಸ್, ದಿಸ್ ಇಸ್ ವೆರಿ, ವೆರಿ ಇಂಪಾರ್ಟೆಂಟ್, ಸ್ಟ್ರೈನ್ ಎನರ್ಜಿ ಇಸ್ ಆಲ್ವೇಸ್ ಪಾಸಿಟಿವ್ ಸ್ಕೇಲಾರ್ ಕ್ವಾಂಟಿಟಿ, whether in compression or tension. So idunnu ಎತ್ತಾಕ್ಬೋದು ನಿಮಗೆ. Strain energy is which type of quantity? Vector, tensor, negative scalar, positive scalar.
Positive scalar.
So it's very, very important. It's always a positive scalar quantity, whether whatever, irrespective of force. ನೀವು ಕಂಪ್ರೆಷನ್ ಕೊಟ್ಟ ತಕ್ಷಣ ನೆಗೆಟಿವ್ ಅಂತ ಹಾಕ್ಬಿಡ್ತೀರಾ, ಯಾಕೆಂದ್ರೆ ನಿಮ್ಗೆ ಏನೋ ಸೈನ್ ಕನ್ವೆನ್ಷನ್, ಕಂಪ್ರೆಷನ್ ನೆಗೆಟಿವ್, ಟೆನ್ಷನ್ ಪಾಸಿಟಿವ್. ಅರ್ಥ ಆಯ್ತಾ? ಸೊ ಈ ತರ ಈ ಪರ್ಟಿಕ್ಯುಲರ್ ಪಾರ್ಟ್ ಅಲ್ಲಿ ಒಂದೊಂದು ಚಿಕ್ಕ ಚಿಕ್ಕ ವಿಷಯಗಳು ತುಂಬಾ ಇಂಪಾರ್ಟೆಂಟ್ ಆಗಿ ಬರ್ತದೆ. ಸ್ಟ್ರೈನ್ ಎನರ್ಜಿ ಇಸ್ ಆಲ್ವೇಸ್ ಎ ಪಾಸಿಟಿವ್ ಸ್ಕೇಲರ್ ಕ್ವಾಂಟಿಟಿ irrespective of type of axial force. It may be in compression or it may be in tension. So any doubts? Any doubts? Full doubt or no doubts sir?
No doubt sir.
Okay. Next, see, this is already I have derived. See, ನಿಮ್ಗೆ ಏನಾಗುತ್ತೆ, ನಾನು ಏನಕ್ಕೆ ಇದರ ತೋರಿಸ್ತೆ ಅಂದ್ರೆ ಆ ನೊಟೇಷನ್ಸ್ ಹೆಂಗ್ ಬೇಕಾದ್ರೂ ಮಾಡಬಹುದು. Here see work done. What is work done? Half into P into delta. What is this? Because of gradual static ಅಂದ್ರೆ ಅವನು ಇದನ್ನ ಲೀನಿಯರ್ ಲೋಡ್ ತಗೊಂಡಿದ್ದಾನೆ.
ಅಲ್ವಾ? ಸೊ ನಿಮ್ಗೆ ಫೈನಲಿ ವಾಟ್ ಈಸ್ ಡಿರೈವ್ಡ್? U equal sigma square 2E into volume. What we derived also the same thing. Okay, but this is for gradual or static load. Gradual or static load. So ಏನ್ ಮಾಡಿಲ್ಲ ಅವನು ಡೈರೆಕ್ಟ್ ಆಗಿ ಲೋಡ್ ವರ್ಸಸ್ ಡಿಫಾರ್ಮೇಶನ್ ಕರ್ವ್ ತಗೊಂಡ, ಅದ್ರದ್ದು ವರ್ಕ್ ಡನ್ ಹಾಕೊಂಡ, ಹಾಫ್ ಇಂಟು ಪಿ ಇಂಟು ಡೆಲ್ಟಾ ಅಂತ ಹಾಕೊಂಡ. ಬಟ್ ವಾಟ್ ಇಸ್ ದ ಅವನ್ ಏನ್ ಮಾಡ್ದ? ನಾನ್ ನಿಮ್ಗೆ ತುಂಬಾ ಸಿಂಪಲ್ ಆಗಿ ಹೇಳ್ಕೊಟ್ಟಿದ್ದೀನಿ, ಬಟ್ ಇದು ಕೊಟ್ರು ಅದು ಕೊಟ್ರು ಎರಡು ಸೇಮ್. ದೇರ್ ಇಸ್ ನೋ ಚೇಂಜ್, ಬೋತ್ ಎಕ್ಸ್ಪ್ರೆಷನ್ ಆರ್ ಸೇಮ್. ಗೊತ್ತಾಯ್ತಾ? ನೀವು ಕನ್ಫ್ಯೂಷನ್ ಏನ್ ಮಾಡ್ಕೋಬೇಡಿ. ಇಲ್ಲಿ ನಾವೇನ್ ಡಿರೈವ್ ಮಾಡಿದ್ದೆ ಹೇಳಿ? U equals, see, we derived two expressions. Just see here what we derived. F square L 2AE. Alva, F square L by 2AE. What he is saying? See, sigma square 2E into volume. What he did, see, ಏನ್ ಮಾಡಿದಾನೆ ಇಲ್ಲಿ? ತುಂಬಾ ಸಿಂಪಲ್. ನಾವೇನಪ್ಪ ಡಿರೈವ್ ಮಾಡಿದ್ದು? F square
L by 2A.
2A E. What is sigma? F by A. What is volume? What is volume? What is volume? Length into
breadth into height.
Breadth into depth or height. Sometimes it's a unity. Let's see. Now what he is doing is, if you write in terms of sigma, ಸಿಗ್ಮಾ ಬೇಕು ಅಂದ್ರೆ ಏನ್ ಮಾಡ್ಬೇಕು? ಮಲ್ಟಿಪ್ಲೈ. ಇಲ್ಲೂ ಅಷ್ಟೇ, ಎ ಮತ್ತೆ ಎ ಇಂದ ಮಲ್ಟಿಪ್ಲೈ ಮಾಡಿದ್ರೆ ಎ ಸ್ಕ್ವೇರ್ ಆಗುತ್ತೆ ಅಲ್ವಾ? ಸೊ ಏನಾಯ್ತು ನಿಮ್ಗೆ? ಸಿಗ್ಮಾ ಸ್ಕ್ವೇರ್ ಇಂಟು ಎಲ್ ಡಿವೈಡೆಡ್ ಬೈ ಎಲ್ ಇಂಟು ಎ ಡಿವೈಡೆಡ್ ಬೈ 2E. 2E. What is L into A? What is area? B into D is?
Yes, sir.
Area. Now what is this?
L into A, volume.
What is the equation? See how indirectly they can ask. Any doubts? ಎಷ್ಟು ಇಂಡೈರೆಕ್ಟ್ ಆಗಿ ಕೇಳಬಹುದು ನಿಮ್ಗೆ ನೋಡಿ. This is nothing but same equation. Sigma U equals sigma in terms of stress he is expressing.
Yes, sir.
See, ಇಲ್ಲಿ ಬೇಕಾದ್ರೆ ನೀವು ಇನ್ನೊಂದು ಕಾಲಮ್ ನ ಆಡ್ ಮಾಡ್ಕೊಂಡ್ಬಿಡ್ಬೋದು ಅದ್ರ ಜೊತೆಗೆ, ಇನ್ ಟರ್ಮ್ಸ್ ಆಫ್ ಸ್ಟ್ರೆಸ್. ಇಲ್ಲ ನಿಮಗೆ ಬೇಸಿಕ್ ಕಾನ್ಸೆಪ್ಟ್ ಫುಲ್ ಗೊತ್ತಿದ್ರೆ ಯಾವುದೋ ಒಂದು ಹಾಕ್ಬಿಟ್ಟು ಆರಾಮಾಗಿ ಮಾಡ್ಬೋದು ಉಳಿದಿದ್ದನ್ನ. ಸೊ ಎನಿ ಡೌಟ್ಸ್? ಮತ್ತೆ ಏನಾದ್ರು ಎಕ್ಸ್ಪ್ಲೈನ್ ಮಾಡ್ಬೇಕಾ? ಅರ್ಥ ಆಯ್ತಾ ಇಲ್ವಾ?
ಎಸ್ ಸರ್.
ನೀನ್ ಒಬ್ಬನೇ ಸರ್ ಅಂತ ಹೇಳ್ಕೊಡೋ, ಉಳಿದವರೆಲ್ಲ ಏನು ಮಾಡ್ತಿರ್ತಾರೆ
ಸರ್? ಇನ್ನೊಂದ್ಸಲ ಮಾಡಿ.
ಕೇಳ್ಬೇಕು. ಸಿ, ಇದು ಫೈನಲ್ ಇಕ್ವೇಶನ್, ನಾವು ಮಾಡಿದ ಇಕ್ವೇಶನ್ ಎರಡು ಸೇಮ್ ಇಕ್ವೇಶನ್. ಓಕೆ, ನಾವು ಈ ಇಕ್ವೇಶನ್ ಡಿರೈವ್ ಮಾಡಿದೀವಿ ಅಲ್ವಾ? ಎಫ್ ಸ್ಕ್ವೇರ್ ಎಲ್ ಬೈ 2AE. ಬಟ್ ವಾಟ್ ಈಸ್ ಸ್ಟ್ರೆಸ್? ಲೋಡ್ ಬೈ ಏರಿಯಾ ಅಲ್ವಾ? ಲೋಡ್ ಬೈ ಏರಿಯಾ. ವಾಟ್ ಈಸ್ ವಾಲ್ಯೂಮ್? ಲೆಂತ್ ಇಂಟು ಬ್ರೆಡ್ತ್ ಇಂಟು ಡೆಪ್ತ್, in which the cross sectional area is A. Here in this equation, if you want stress, denominator and numerator should be multiplied by A, because F square by A square is sigma square. So that's why I multiplied by A. I have taken sigma square. But what if here L is remains same? What is L into A? What is L into A? What is A? That is volume. Length into A, it is volume. So finally this equation will become sigma square into volume divided by 2E. The same thing. So ಇದನ್ನ ಇನ್ನೊಂದು ಟರ್ಮ್ ಎಂತ ಹೇಳ್ಬೋದು? ಸ್ಟ್ರೈನ್ ಎನರ್ಜಿ ಡ್ಯೂ ಟು ಗ್ರಾಜುಯಲ್ ಆರ್ ಸ್ಟ್ಯಾಟಿಕ್ ಲೋಡ್. The equation is U equal the same equation, F square L by 2AE, or sigma square by 2E into volume, or in terms of displacement, delta square AE by 2L. So any doubts?
Sir.
No, sir.
Next.
Excuse me, sir.
Hero. Sir,
Excuse me, sir.
Yes, ಏನಮ್ಮ?
Sir, ಸ್ವಲ್ಪ ಸ್ಲೈಡ್ ಮಾಡಿ. Sir, ಇದು ವರ್ಕ್ ಡನ್ ಇಸ್ ಈಕ್ವಲ್ ಟು ಹಾಫ್ ಪಿ ಇಂಟು ಡೆಲ್ಟಾ ಏನಿದೆ ಅಲ್ಲ ಸರ್, ಡಿಸ್ಪ್ಲೇಸ್ಮೆಂಟ್. ಆ ಡಿಸ್ಪ್ಲೇಸ್ಮೆಂಟ್ ಇ ಇಂಟು ಎಲ್ ಹೇಗೆ ರಿಪ್ಲೇಸ್ ಮಾಡಿದ್ರು ಸರ್ ಅದನ್ನು?
ಇ ಇಂಟು ಎಲ್ಲ
Yes,
See,
sir.
what is the thing is, what is your strain? Change in length by
Original.
original length. Now, what is delta?
EL.
ಅರ್ಥ ಆಯ್ತಾ?
Yes, sir.
ಗೊತ್ತಾಯ್ತಪ್ಪ?
Yes, sir. Thank you, sir.
ಓಕೆ ಮಾ. ಸಿ, ಏನೇ ಇದ್ರು ಕೇಳಿ, ಡೌಟ್ ಏನೇ ಇದ್ರು ಕೇಳಿ. ನಿಮಗೆ ಪ್ರೆಸೆಂಟೇಶನ್ ಕಳ್ಸಿರ್ತೀನಿ. ಐ ಥಿಂಕ್ ಲಾಸ್ಟ್ 2 ಕ್ಲಾಸಸ್ ಕಳ್ಸಿದೀನಿ, ಬಂದಿದೆ ಅನ್ಸುತ್ತೆ. ನೋಟ್ ಮಾಡ್ಕೋಬೇಕು ನೀವು. ಇದು ಸ್ಟ್ರಕ್ಚರ್ಸ್ ನೋಡಿದ್ರೆ ಬರಲ್ಲ. ಸ್ಟ್ರಕ್ಚರ್ಸ್ ನೋಡಿದ್ರೆ ಬರಲ್ಲ. ನೀವು ನೋಟ್ ಮಾಡ್ಕೊಂಡು ಕಲಿಬೇಕು. ಓಕೆ. So any doubts? Shall I move to next thing?
Yes, sir.
Okay. See, ಈಗಿನ್ನೂ ಹೇಳ್ತಾ ಇದ್ರಿ ಸರ್ ರೆಸಿಲೆನ್ಸ್ ಅಂತ. See, what is resilience? It is the ability of material to absorb energy when it is deformed elastically and release that energy upon loading. ನೀನ್ ಕೇಳ್ತಾ ಇದ್ದೆ ಯಾರೋ ನೋಡು ಬಂದೇ ಬಿಡ್ತು ರೆಸಿಲೆನ್ಸ್ ಅನ್ನೋ ಟಾಪಿಕ್ ಇದರಲ್ಲಿ. ಸೇಮ್ ಥಿಂಗ್ ಅಲ್ವಾ? ಸೇಮ್ ಥಿಂಗ್. ಇಟ್ ಈಸ್ ಆಲ್ಸೋ ರೆಫರ್ಡ್ ಆಸ್, ಸಿ ಇದೇ ಕ್ವಶನ್ ನಿಮ್ಗೆ ಎತ್ತಾಕ್ಬೋದು. ಸ್ಟ್ರೈನ್ ಎನರ್ಜಿ, ಇಟ್ಸ್ ಆಲ್ಸೋ ರೆಫರ್ಡ್ ಆಸ್ ಸ್ಟ್ರೈನ್ ಎನರ್ಜಿ ಡೆನ್ಸಿಟಿ. ಸ್ಟ್ರೈನ್ ಎನರ್ಜಿ ಡೆನ್ಸಿಟಿ ಅಂತ ಕರೀತಾರೆ. ಇಟ್ ಈಸ್ ಡಿನೋಟೆಡ್ ಬೈ ಮ್ಯೂ. ಸಿ, ಇಲ್ಲಿ ಮ್ಯೂ ಈಕ್ವಲ್ಸ್ ಸಿಗ್ಮಾ ಸ್ಕ್ವೇರ್ ಬೈ 2e ಅಷ್ಟೇ. ಅಂದ್ರೆ ಈಗ ಮೇಲ್ಗಡೆ ಈಕ್ವೇಶನ್ ಅಬ್ಸರ್ವ್ ಮಾಡಿ ನೀವು. See, in this equation, U equals resilience into volume. So ನಿಮ್ಗೆ ಇದನ್ನು ಸಹ ಕೊಡಬಹುದು ಆಪ್ಷನ್ ಅಲ್ಲಿ, ಎಲ್ಲಿ MCQ ನಲ್ಲಿ. The strain energy equals resilience into volume. See, resilience density into volume, ಬರೀ resilience ಅಲ್ಲ. Resilience density in multiplied by, it's a product of resilient density into volume. Why? ನೀವು ಈ ಈಕ್ವೇಶನ್ ನೆನ್ಪಿಟ್ಬಿಟ್ರೆ ನಿಮ್ಗೆ ರೆಸಿಲೆನ್ಸ್ ಮೇಲೆನೆ ನಿಮ್ಗೆ ಕ್ವಶನ್ಸ್ ಹಾಕ್ಬೋದು. ರೆಸಿಲೆನ್ಸ್ ಮೇಲೆನೆ ನಿಮ್ಗೆ ಕ್ವಶನ್ ಹಾಕ್ಬೋದು ಅಲ್ವಾ? ದೇ ಕ್ಯಾನ್ ಪುಟ್ ಎ ಕ್ವಶನ್ ಆನ್ ರೆಸಿಲೆನ್ಸ್. ಕಂಪ್ಯೂಟ್ ದಿ ರೆಸಿಲೆನ್ಸ್, ಕಂಪ್ಯೂಟ್ ದಿ ರೆಸಿಲೆನ್ಸ್, ಕಂಪ್ಯೂಟ್ ದಿ ರೆಸಿಲೆನ್ಸ್ ಆರ್ ರೆಸಿಲೆನ್ಸ್ ಈಕ್ವೇಶನ್ ಯಾವ್ದನ್ನಾರು ಕೊಡ್ಬೋದು. ರೆಸಿಲೆನ್ಸ್ ಈಕ್ವೇಶನ್ ಏನು? ಸಿಗ್ಮಾ ಸ್ಕ್ವೇರ್ ಬೈ 2e. ಸೊ ಇಲ್ಲ ನಿಮಗೆ ಪ್ರಾಬ್ಲಮ್ ಕೊಡ್ಬೇಕಾದ್ರೆ ವಾಲ್ಯೂಮ್ ಮತ್ತೆ ರೆಸಿಲೆನ್ಸ್ ಕೊಟ್ಬಿಟ್ಟು ಸ್ಟ್ರೈನ್ ಎನರ್ಜಿ ಕಂಪ್ಯೂಟ್ ಮಾಡಿ ಅಂತ ಕೇಳ್ಬೋದು. Volume and resilience, they may give volume and resilience, and they may ask to compute strain energy. What is the strain energy stored inside the member? See, this particular topic is raw topic. So raw topic andre, which in the sense you have to involve more number of equations. ಗೊತ್ತಾಯ್ತಾ? ಬರ್ಕೊಳ್ತಾ ಇರಬೇಕು, ಎಲ್ಲ ಅಲ್ಲೇ ಇರುತ್ತೆ. So any doubts in resilience? Any doubts in resilience?
ಸರ್ ಇದೇನೋ ಹೇಳಿದ್ರು ಸಿನಿಮಾ ಮಾಡಿ ಸರ್.
ಏನಮ್ಮ?
ರೆಸಿಲೆನ್ಸ್ ಇಂಟು ಡೆನ್ಸಿಟಿ ಇಂಟು ವಾಲ್ಯೂಮ್.
ಹಾ, this one na?
ಹಾ ಸರ್.
See, what is resilience? Resilience is the energy stored. This particular part. What is this particular part? You just see here. What is this particular part? Half into P into delta, right? What is half into P into delta? This particular part. Half into sigma E into AL. Once again, if you alter this, you are getting this equation only. Volume bit. Andre, ಈ ವಾಲ್ಯೂಮ್ ಆಫ್ ದಿ ಬಾಡಿ ತೆಗೆದ್ಬಿಡಿ. ಈ ವಾಲ್ಯೂಮ್ ಆಫ್ ದಿ ಬಾಡಿ ತೆಗೆದ್ರೆ ವಾಟ್ ಇಸ್ ದ ಈಕ್ವೇಶನ್ ರಿಮೈನಿಂಗ್? ಸಿಗ್ಮಾ ಸ್ಕ್ವೇರ್ ಬೈ 2e. ಸೊ ದಟ್ ಈಸ್ ದಿಸ್ ಪರ್ಟಿಕ್ಯುಲರ್ ಎನರ್ಜಿ, ದಟ್ ಈಸ್ ರೆಸಿಲೆನ್ಸ್ ಆರ್ ರೆಸಿಲೆನ್ಸ್ ಡೆನ್ಸಿಟಿ. ನೌ ದ ಸ್ಟ್ರೈನ್ ಎನರ್ಜಿ ವಿಚ್ ಇಸ್ ಈಕ್ವಲ್ ಟು ರೆಸಿಲೆನ್ಸ್ ಡೆನ್ಸಿಟಿ multiplied by volume. ಸೊ ಇಲ್ಲಿ ನೀವು ರೆಸಿಲೆನ್ಸ್ ಡೆನ್ಸಿಟಿ ನೀವೇನೇನು ನೆನ್ಪಿಟ್ಕೋಬೇಕು? just sigma square into 2e. What is that sigma square into 2e? See, this resonance density here, sigma square into 2e into volume. ಗೊತ್ತಾಯ್ತಾ? ನಿಮ್ಗೆ ಈ ಪ್ರಾಬ್ಲಮ್ ನಲ್ಲಿ ಸ್ಟ್ರೈನ್ ಎನರ್ಜಿ ಕಂಪ್ಯೂಟ್ ಮಾಡಿ ಅಂದ್ಬಿಟ್ಟು ರೆಸಿಲೆನ್ಸ್ ಡೆನ್ಸಿಟಿ ವ್ಯಾಲ್ಯೂ ಡೈರೆಕ್ಟ್ ಆಗಿ ಕೊಟ್ಬಿಟ್ಟು ವಾಲ್ಯೂಮ್ ಆಫ್ ದಿ ಮೆಂಬರ್ ನ ತೋರಿಸ್ಬಿಡ್ಬೋದು ಫಿಗರ್ ಅಲ್ಲಿ. ಅವಾಗ ನೀವು L into B into H ಹಾಕ್ಬಿಟ್ಟು ವಾಲ್ಯೂಮ್ ಕಂಪ್ಯೂಟ್ ಮಾಡ್ಕೋಬೇಕು. ಗೊತ್ತಾಯ್ತಾ? Yes, any doubts? So that is resilience density. It is the ability of material absorb when it is deformed elastically. So which means this much elastic limit ಎಲ್ಲಿ ಬರುತ್ತೆ ನಿಮಗೆ? ಇಷ್ಟೇ linear. ಇದೇ resilience ನಿಮಗೆ. ಇಷ್ಟೇ resilience.
Yes, sir.
This is resilience. ಸೊ ಅದಕ್ಕೆ ನಿಮಗೆ ಇದನ್ನೆಲ್ಲ ನಾನು ಫಸ್ಟ್ ಕ್ಲಾಸ್ ಅಲ್ಲೇ ಪ್ರಾಪರ್ಟಿ ಎಲ್ಲ ಮಾಡ್ಬಿಟ್ಟಿದ್ದೀನಿ. ಆಸ್ ಪರ್ ಸಿಲೆಬಸ್ ಹೋದ್ರೆ ಅದನ್ನೆಲ್ಲ ಹೇಳ ಹಾಗೆ ಇಲ್ಲ. ನಾವು ಡೈರೆಕ್ಟ್ ಆಗಿ ಪ್ರಿನ್ಸಿಪಲ್ ಸ್ಟ್ರೆಸ್ ಬರ್ಬೇಕು. ನಾನ್ ಡೈರೆಕ್ಟ್ ಆಗಿ ಪ್ರಿನ್ಸಿಪಲ್ ಸ್ಟ್ರೆಸ್ ನಿಮ್ಗೆ ಹೇಳಿದ್ರೆ ಇಲ್ಲಿ ನಿಮ್ಗೆ ಏನಂದ್ರೆ ಏನು ಗೊತ್ತಾಗ್ತಾ ಇರ್ಲಿಲ್ಲ. ಗೊತ್ತಾಯ್ತಂಡ್ರೋ? ಸೊ ಇವಾಗ ನೋಡಿ, ನೀವೇ ನಾನು ಇದು ಮಾಡಕ್ ಮುಂಚೆನೆ ರೆಸಿಲೆನ್ಸ್ ಬರುತ್ತಾ ಸರ್ ಅಂತ ಕೇಳಿದ್ರಿ. ವೈ? ಬಿಕಾಸ್ ಯು ನೋ ದಟ್ ರೆಸಿಲೆನ್ಸ್ ಮೀನ್ಸ್ ದಿಸ್ ಇಸ್ ದ ಎನರ್ಜಿ ವಿತ್ ಇನ್ ಎಲಾಸ್ಟಿಕ್ ಲಿಮಿಟ್ ಅಂತ. ಗೊತ್ತಾಯ್ತಾ? ಅಂಡ್ ಈಕ್ವೇಶನ್ ಇವಾಗ ಬರ್ದಿಟ್ಕೊಡಿ. ನಿಮ್ ಕೆಲವು ಟೈಮಲ್ಲಿ ಸ್ಟ್ರೆಸ್ ಕೊಟ್ಬಿಟ್ಟು ಯಂಗ್ಸ್ ಮಾಡಲ್ಸ್ ಕೊಟ್ಬಿಟ್ಟು ರೆಸಿಲೆನ್ಸ್ ಕೇಳ್ಬಿಡ್ತಾನೆ. ಸ್ಟ್ರೆಸ್ ಯಂಗ್ಸ್ ಮಾಡಲ್ಸ್ ಕೊಟ್ಟು ರೆಸಿಲೆನ್ಸ್ ಕಂಪ್ಯೂಟ್ ಮಾಡಿ ಅಂತ ಕೇಳ್ತಾನೆ. ಓಕೆ, shall I move on to next slide? Now see, strain energy due to volumetric stress. See this, ಈ ಜನರಲಿ ಈ ವಾಲ್ಯೂಮೆಟ್ರಿಕ್ ಸ್ಟ್ರೆಸ್ ಅನ್ನೋದು ನಿಮ್ಗೆ ಪ್ರಾಬ್ಲಮ್ ಅಲ್ಲಿ ಬರುತ್ತೆ, ಇಲ್ಲ ಡೈರೆಕ್ಟ್ ಈಕ್ವೇಶನ್ ಆಗ್ತಾನಪ್ಪ. ಈ ಈಕ್ವೇಶನ್ ನೆನ್ಪಿಟ್ಕೋಬೇಕು. 2E ಅಲ್ಲ ಇದು. ವಾಲ್ಯೂಮೆಟ್ರಿಕ್ ಅಂತ ಬಂದ ತಕ್ಷಣ ಐ ಆಮ್ ಟಾಕಿಂಗ್ ಅಬೌಟ್ ಬಲ್ಕ್ ಮಾಡ್ಯುಲಸ್. 2K into ವಾಲ್ಯೂಮ್. ಸೇಮ್ ಈಕ್ವೇಶನ್ ಯಾವ್ದು ನೋಡಿ. ಇದಕ್ಕೆ ಏನ್ ಬರ್ತದೆ, ಯಾವ್ದಕ್ಕೆ ನೀವು ಎಷ್ಟು ಸಿಂಪಲ್ ಆಗಿ ನೆನ್ಪಿಟ್ಕೋಬೇಕಂದ್ರೆ ಈ ಸೇಮ್ ಈಕ್ವೇಶನ್ ಸಿಗ್ಮಾ ಸ್ಕ್ವೇರ್ 2E into ವಾಲ್ಯೂಮ್. ಇನ್ಸ್ಟೆಡ್ ಆಫ್ 2E ಯು ಮಸ್ಟ್ ಟೇಕ್ 2K ಅಷ್ಟೇ. ವಾಲ್ಯೂಮ್ ಸ್ಟ್ರೈನ್ ಎನರ್ಜಿ ಡ್ಯೂ ಟು ವಾಲ್ಯೂಮೆಟ್ರಿಕ್ ಸ್ಟ್ರೆಸ್ ಅಂತ ಬರ್ಕೊಳ್ಳಿ. ಅಲ್ಲಿ ಇನ್ಸ್ಟೆಡ್ ಆಫ್ ವಾಟ್? ಇನ್ಸ್ಟೆಡ್ ಆಫ್ ಯಂಗ್ಸ್ ಮಾಡ್ಯುಲಸ್ you have to consider bulk modulus. ಅಷ್ಟೇ, ನೆನ್ಪಿಟ್ಕೊಳ್ಳೋದು ತುಂಬಾ ಈಸಿ. What is bulk modulus? Elastic constants ಎಲ್ಲ ಹೇಳ್ಕೊಟ್ಟಿದ್ದೀನಿ. What is bulk modulus? What is bulk modulus? It is a ratio of
volumetric shape.
Yes, volumetric stress to volumetric strain.
Yes, sir.
ಅಷ್ಟೇ, ಇನ್ನೇನಿಲ್ಲ. ಗೊತ್ತಾಯ್ತಾ? ಸೊ ಎನಿ ಡೌಟ್ಸ್ ಇನ್ ದಿಸ್ ಈಕ್ವೇಶನ್?
No, sir.
ತುಂಬಾ ಸಿಂಪಲ್ ಆಗಿ ನೆನ್ಪಿಟ್ಕೊಳಕ್ ಟ್ರೈ ಮಾಡಿ, ಕಾಂಪ್ಲಿಕೇಟ್ ಮಾಡ್ಕೋಬೇಡ್ರಿ. ಅವನ್ ಯಾವ ತರ ಕೇಳಿದ್ರು ನಿಮ್ಗೆ ಅಲ್ಲೇ ನಿಮ್ಗೆ ಕಾನ್ಸೆಪ್ಟ್ ವಾಲ್ಯೂಮೆಟ್ರಿಕ್ ಅಂತ ಬಂದ ತಕ್ಷಣ ದೇರ್ ಇಸ್ ನೋ ಯಂಗ್ಸ್ ಮಾಡ್ಯುಲಸ್, ದೇರ್ ವಿಲ್ ಬಿ ಎ ಮಾಡ್ಯುಲಸ್, ಬಲ್ಕ್ ಮಾಡ್ಯುಲಸ್. ಕ್ಲಿಯರ್? ಬಲ್ಕ್ ಮಾಡ್ಯುಲಸ್ ಆಫ್ ದಿ ಮೆಟೀರಿಯಲ್. So any doubts? See, I have given so many subdivisionary equations. ನಾನು ನಿಮ್ಗೆ ಪ್ರೆಸೆಂಟೇಶನ್ ಅಲ್ಲೇ ಒಂದು ಒಳ್ಳೆ ಈಕ್ವೇಶನ್ಸ್ ಗಳು ಬೇರೆ ತರ ಕೊಟ್ಟೆ. ಈ PPT ಅಲ್ಲಿ ನಿಮ್ಗೆ ಬೇರೆ ತರ ಈಕ್ವೇಶನ್ಸ್ ಬರ್ತಾ ಇದೆ. ಕ್ಲಿಯರ್? ಎನಿ ಡೌಟ್ಸ್? ಬಟ್ ಎರಡನ್ನೂ ಸೇಮ್ ಲೈನ್ಸ್ ಅಲ್ಲೇ ಇರುತ್ತೆ, ನೀವ್ ಏನು ತಲೆ ಕೆಡಿಸ್ಕೊಳ್ಳೋಕೆ ಹೋಗಿಲ್ಲ. ಬಟ್ ದೇ ಮೇ ಸೆಟ್ ಹೌಎವರ್ ಇಟ್ ಮೇ ಬಿ. ಅವ್ರಿಗೆ ಫುಲ್ ಫ್ಲೆಕ್ಸಿಬಿಲಿಟಿ ಇದೆ, ಹೆಂಗಾದ್ರೂ ಸೆಟ್ ಮಾಡ್ಬೋದು. ಬಟ್ ನೀವು ಮಾತ್ರ ಎಲ್ಲದಕ್ಕೂ ರೆಡಿ ಇರ್ಬೇಕು. ಕ್ಲಿಯರ್? Shall I move on to next slide? See, ಟಾರ್ಷನ್. ನಿಮ್ಗಲ್ಲಿ ಟಾರ್ಷನ್ ನಾನು ನಿಮ್ಗಲ್ಲಿ ಹೇಳಿಲ್ಲ. ನಾನು ಏನೇನು ಹೇಳಿದೆ? ಆಕ್ಸಿಯಲ್ ಫೋರ್ಸ್ ಹೇಳಿದೆ, ಫ್ಲೆಕ್ಚರ್ ಹೇಳಿದೆ. Now I am talking about torsion. If we are doing twist, which type of force will come into picture? T. Torsional force T. ಏನು ಚೇಂಜ್ ಇಲ್ಲ. ಹಾಫ್ ಇಂಟು T θ ಆಯ್ತು. ಅಲ್ಲೆಲ್ಲ ಏನಾಯ್ತು? ಹಾಫ್ ಇಂಟು F ಡೆಲ್ಟಾ, ಹಾಫ್ ಇಂಟು M θ, ಇಲ್ಲಿ ಹಾಫ್ ಇಂಟು T θ. ಸಿ, ನಿಮಗೆ ಬರೀ ಇದ್ರಲ್ಲೇನೆ ಕ್ವಶನ್ಸ್ ಗಳು ಸೆಟ್ ಮಾಡ್ಬೋದು. ವಾಟ್ ಇಸ್ ದ ವರ್ಕ್ ಡನ್ ಅಂತಾನೆ. ಹಾಫ್ ಇಂಟು T θ ಆಯ್ತು. ಬಟ್ ಇಲ್ಲಿ ಅಲ್ಲಿ ಬೆಂಡಿಂಗ್ ಈಕ್ವೇಶನ್ ಯೂಸ್ ಮಾಡಿದ್ರಿ, ಇಲ್ಲಿ ಟಾರ್ಷನ್ ಈಕ್ವೇಶನ್. ವಾಟ್ ಇಸ್ ಟಾರ್ಷನ್ ಈಕ್ವೇಶನ್? T by J,
I by J, theta by
T by J equals G theta by L,
G theta by L.
Which is equal to what? What is the torsion equation?
Yes, sir.
T by J equals G theta by equals ಇನ್ನೊಂದು term ಬಿಟ್ರಿ. This is stiffness equation. What is strength equation? Tau by R. Check the torsion equation. Check ಮಾಡಿ. What is the torsion equation? See, ನಿಮ್ಗೆ ಎಷ್ಟು ಬ್ಯೂಟಿಫುಲ್ ಆಗಿ ಮಾಡಿದ್ದಾರೆ ಸಿಲೆಬಸ್ ಅಂದ್ರೆ ಟಾರ್ಷನ್ ಎಲ್ಲ ಇಲ್ಲ ನಾವು ಓದಲ್ಲ ಅಂತ ಬಿಟ್ರೆ ಇದ್ರಲ್ಲೆಲ್ಲ ಬರುತ್ತೆ ಅಲ್ವಾ? ವಿಚ್ ಈಸ್ ಈಕ್ವಲ್ ಟು ಟೌ ಬೈ ಆರ್ ಇದು. ಸೊ ದೀಸ್ ಟೂ ಥಿಂಗ್ಸ್ ಆರ್ ಕಾಲ್ಡ್ ಸ್ಟ್ರೆಂತ್ ಈಕ್ವೇಶನ್. These two things are called stiffness equation. Illi, in the place of T, he replaced the thing. Finally, he is arriving U equals tau square divided by 4g into V. See, ಇದು generally ನಿಮಗೆ numerical ಇದ್ರ ಮೇಲೆ ಬರಲ್ಲ, equation ಮಾತ್ರ ನೀವು ನೆನಪಿಟ್ಕೋಬೇಕು. ನ್ಯೂಮರಿಕಲ್ ಕೇಳಲ್ಲ
ಸರ್, ನ್ಯೂಮರಿಕಲ್ಸ್ ಬರಲ್ರಿ ಸರ್.
ಟಾರ್ಷನ್ ಮೇಲೆ ಕೇಳಲ್ಲ ನ್ಯೂಮರಿಕಲ್.
ಓಕೆ ಸರ್.
ಸ್ಟ್ರೈನ್ ಎನರ್ಜಿ ಡ್ಯೂ ಟು ಟಾರ್ಷನ್ ನಿಮ್ಗೆ ಇಲ್ಲ. ಆಸ್ ಪರ್ ಸಿಲಬೈ ನೀವು ನೋಡಕ್ ಹೋದ್ರೆ ನಿಮ್ಮ ಸ್ಟ್ರಕ್ಚರ್ಸ್ ಅಲ್ಲಿ ನಿಮ್ಗಿರೋದು ಬರೀ ಅಂದ್ರೆ ನಿಮ್ UG ಲೆವೆಲ್ ಸ್ಟ್ರಕ್ಚರ್ಸ್ ಅಲ್ಲಿ ನಿಮಗಿರೋದು ಆಕ್ಸಿಯಲ್ ಫೋರ್ಸ್ ಫ್ಲೆಕ್ಷರ್ ಎರಡೇ. ಬಟ್ ಇದು ಅಡಿಷನಲ್ ನೀವು ತಲೆಯಲ್ಲಿ ಇಟ್ಕೊಂಡಿರಿ. ಈಕ್ವೇಶನ್ಸ್ ಕೇಳ್ಬೋದು, ಅವನು ಈಕ್ವೇಶನ್ಸ್ ಕೇಳ್ಬೋದು. ಟೌ ಸ್ಕ್ವೇರ್ ಡಿವೈಡೆಡ್ ಬೈ 4g ಇಂಟು ವಿ ವಾಲ್ಯೂಮ್. ಇಲ್ಲಿ ಸಿ ಏನಿಲ್ಲಪ್ಪ ನಿಮ್ಗೆ, ನೀವು ಎಷ್ಟು ಈಸಿಯಾಗಿ ಫೈಂಡ್ ಔಟ್ ಮಾಡ್ಬೋದು ಗೊತ್ತಂಡ್ರೋ. ಸಿ ಇಲ್ಲಿ ಡಿಫ್ರೆನ್ಸ್ ಏನಪ್ಪಾ, ಇಲ್ಲಿ ಡಿಫ್ರೆನ್ಸ್ ಬಂದು ಕೆ, ಇಲ್ಲಿ ಇ. ಸಿ ಅದೇ ತರ ನೀವು ಇಲ್ಲಿಗೆ ಬಂದ್ರೆ ಇಲ್ಲಿ ಜಿ ಅಂಡ್ ಟೌ ಸ್ಕ್ವೇರ್. ಸಿ ಟೌ ಸ್ಕ್ವೇರ್ ಬೈ 4g ಇಂಟು ವಾಲ್ಯೂಮ್. ಬಟ್ ಅದೇ ಮೇಲ್ಗಡೆ ಬಂದ್ರೆ 2 ಸಿಗ್ಮಾ ಸ್ಕ್ವೇರ್ ಬೈ 2k. ಇನ್ನೆಲ್ಲ 2k ಇರುತ್ತೆ. ಇದಕ್ಕೆ ಬಂದ್ರೆ ಇದ್ರಲ್ಲಿ ಬಂದ್ರೆ ಟಾರ್ಷನ್ ಅಲ್ಲಿ, ಬಿಕಾಸ್ ಟಾರ್ಷನ್ ಮೋರ್ ಎಫೆಕ್ಟಿವ್ ಅಲ್ವಾ. ನೀವು ಟಾರ್ಷನಲ್ ಫೋರ್ಸ್ ಅಂದ್ರೆ ಏನ್ ಎಕ್ಸಾಂಪಲ್, ನೀವು ಬಟ್ಟೆ ಹೆಣ್ತೀರಲ್ಲ ಗೊತ್ತಾ, ಒಂದ್ ಕೈ ಇಟ್ಕೊಂಡು ಇನ್ನೊಂದ್ ಕೈ ಬಟ್ಟೆ ಹೆಂಗ್ ಹೆಣ್ತೀರಾ, ಒಂದ್ ಎಂಡ್ ಫಿಕ್ಸ್ಡ್, ಇನ್ನೊಂದ್ ಎಂಡ್ ರೊಟೇಟ್ ಮಾಡ್ತೀರಾ ನೀರು ತೆಗಿಕ್ಕೆ. ದಟ್ ಈಸ್ ಟಾರ್ಷನ್ ಫೋರ್ಸ್. ಅರ್ಥ ಆಯ್ತಾ? ಟಾರ್ಷನ್ ಅಂದ್ರೆ ಏನಂತ, ಟ್ವಿಸ್ಟ್ ಮಾಡ್ತೀರಲ್ವಲ್ರೋ, ಬಟ್ಟೆ ಒಂದ್ ಎಂಡಲ್ಲಿ ಇಟ್ಕೊಂಡು ಇನ್ನೊಂದ್ ಎಂಡ್ ರೌಂಡ್ ಹೊಡಿತೀರಲ್ಲ, ದಟ್ ಈಸ್ ಟಾರ್ಷನ್. ಕ್ಲಿಯರ್? ಎನಿ ಡೌಟ್ಸ್? Any doubts?
No, sir.
Okay, so ನಿಮಗೆ ಕ್ಲಿಯರ್ ಇರಲಿ this equation. So U equals tau shear stress, tau square 4g into. ಈಗ ನನ್ನ ಪ್ರಶ್ನೆ, what is the resilience? What is the resilience under torsion? What is the resilience under torsion?
Tau square by 4g.
That's all. The resilience under torsion is tau square by 4g. What is the resilience under volumetric stress?
Tau square by 2k.
Not tau, sigma square by 2k. Sigma square by 2k. What is the resilience under static load? Sigma square by 2e.
Right.
See, ಇದನ್ನು ಕ್ವಶನ್ ಸೆಟ್ ಮಾಡಬಹುದು. Clear? Any doubts? Any doubts? ಸರ್ ಇಲ್ಲ ಡೌಟ್ ಇದೆ ಸರ್ ಅನ್ನಿ, ಇಲ್ಲ ಓಕೆ ಸರ್ ಅನ್ನಿ, ಮುಂದೆ ಹೋಗ್ಬೋದು ನಾವು. ಓಕೆ, ಎಸ್. ಸಿ ಸ್ಟ್ರೈನ್ ಎನರ್ಜಿ ಡ್ಯೂ ಟು ಶಿಯರ್ ಸ್ಟ್ರೆಸ್. ಜಸ್ಟ್ ಈಕ್ವೇಶನ್ ಅನ್ನು ನೆನಪಿರ್ಬೇಕು ನಿಮ್ಗೆ. ವಾಟ್ ಇಸ್ ದ ಈಕ್ವೇಶನ್? ಟೌ ಸ್ಕ್ವೇರ್ ಬೈ 2g ಇಂಟು ವಾಲ್ಯೂಮ್. ಸಿ ಶಿಯರ್ ಸ್ಟ್ರೆಸ್ ಬಂದ್ರೆ 2g. ಅದೇ ನಿಮ್ಗೆ ಇನ್ನೊಂದು ಸ್ಟ್ರೆಸ್ ಯಾವ್ದು ನಾನು ಹೇಳಿದ್ದು, ವಾಲ್ಯೂಮೆಟ್ರಿಕ್ ಸ್ಟ್ರೆಸ್ ಬಂದ್ರೆ ಸಿಗ್ಮಾ ಸ್ಕ್ವೇರ್ ಬೈ 2k. ಅಲ್ಲಿ ಸಿಗ್ಮಾ, ಇಲ್ಲಿ ಟೌ ಶಿಯರ್ ಇರೋದ್ರಿಂದ. ಕ್ಲಿಯರ್? ಎನಿ ಡೌಟ್ಸ್? ಎನಿ ಡೌಟ್ಸ್? ಗೊತ್ತಾಯ್ತಾ? ಸೊ ದಿಸ್ equation is clear. This is also important equation. This is also very, very important equation. What is the strain energy due to bending? This you know that U equals 0 to L m square dx into 2EI. ಇದನ್ನು ಡಿರೈವ್ ಸಹ ಮಾಡಿದೀವಿ ನಾವು. ಕ್ಲಿಯರ್? ಸೊ ನೋಡಿ ಎಷ್ಟು ಟೈಪ್ ಆಫ್ ಫೋರ್ಸಸ್ ಬರ್ತದೋ ಅಷ್ಟೂ ಟೈಪ್ ಆಫ್ ಫೋರ್ಸ್ ನಲ್ಲಿ ಸ್ಟ್ರೈನ್ ಎನರ್ಜಿ, ಜನರಲ್ ಸ್ಟ್ರೈನ್ ಎನರ್ಜಿ ಈಕ್ವೇಶನ್ ಅನ್ನ ಡಿರೈವ್ ಮಾಡಿದೀವಿ. ಎನಿ ಡೌಟ್ಸ್? ಒಂದ್ ಕಡೆ ಬರ್ದಿಟ್ಕೊಂಡಿದ್ದೀರಾ ಅಲ್ವಾ? ಡಿರೈವ್ ಮಾಡಿದ್ವಿ. See, the first thing is this is due to axial load, sigma square by 2e into volume, and this is due to volumetric stress, sigma square by 2k into volume, and this is due to torsion, tau square by 4g into volume, and this is due to shear stress. Tau square by 2g into volume, and one more is due to bending. Integral bending ಅಲ್ಲಿ ಮಾತ್ರ integration ಬರುತ್ತೆ ನಿಮಗೆ. ಇನ್ನೆಲ್ಲ summation, ಇನ್ನೆಲ್ಲದರಲ್ಲೂ summation. Integral of 0 to L m square into dx divided by 2i. Clear? See, next to ಇಲ್ಲಿ ನೋಡಿ, due to various types of axial loads. Axial loads ಅಲ್ಲಿ ನಿಮಗೆ ಒಂದು ಗ್ರಾಜುಯಲಿ ಲೋಡ್ ಅಪ್ಲೈ ಮಾಡಬಹುದು, ಸಡನ್ಲಿ ಲೋಡ್ ಅಪ್ಲೈ ಮಾಡಬಹುದು. ಕೆಲವು ಟೈಮ್ ನಿಮಗೆ ಪಿ ಡೆಲ್ಟಾ ಡಯಾಗ್ರಾಮ್ ನ ಐಡೆಂಟಿಫೈ ಮಾಡಿ ಅಂತ ಕೊಟ್ಬಿಡ್ತಾನೆ. ಪಿ ಡೆಲ್ಟಾ ಡಯಾಗ್ರಾಮ್ ಗ್ರಾಜುಯಲಿ ಅಪ್ಲೈಡ್ ನೋಡ್ಗೆ ಬರೀ ಒನ್ ಟ್ರಯಾಂಗಲ್, ಸಡನ್ಲಿ ಅಪ್ಲೈಡ್ ಗೆ ಫುಲ್ ಎನರ್ಜಿ ಕಟ್ಟೆ ಆಗೋಗ್ಬಿಡುತ್ತೆ. ಗ್ರಾಜುಯಲಿ ಅಪ್ಲೈಡ್ ಏನ್ ಮಾಡುತ್ತೆ, ಆ ಎನರ್ಜಿ ಅದ್ ಮತ್ತೆ ಒರಿಜಿನಲ್ ಪೊಸಿಷನ್ ಬರಕ್ ಟ್ರೈ ಮಾಡುತ್ತೆ, ಮತ್ತೆ ಒರಿಜಿನಲ್ ಪೊಸಿಷನ್ ಬರಕ್ ಟ್ರೈ ಮಾಡುತ್ತೆ. ಸಡನ್ ಆಗಿ ಮುರಿದೋದ್ರೆ ಏನು, ಎನರ್ಜಿ ಡಮಾರ್ ರೆಕ್ಟಾಂಗಲ್ ಆಗ್ಬಿಡ್ತದೆ. ಅದಕ್ಕೇನೆ ಅದ್ರದ್ದು 2p/a, ಅದಕ್ಕೆ ಇದ್ರದ್ದು p/a. ಆಕ್ಚುಲಿ ಇದೊಂದು MCQ ನಾನು ಮಾಡಿದ್ದೆ ಅನ್ಸುತ್ತೆ, ಗ್ರಾಜುಯಲಿ ರೇಷಿಯೋ ಆಫ್ ಸಡನ್ಲಿ ಅಪ್ಲೈಡ್ ಲೋಡ್ ಟು ಗ್ರಾಜುಯಲಿ ಅಪ್ಲೈಡ್ ಲೋಡ್ ಅಂತ. ಎಸ್, ಅರ್ಥ ಆಯ್ತಲ್ವಾ? ಅದು ಇಲ್ಲಿ ಬಂತು ನೋಡಿ. ಅದು ಯಾಕೆ ಅಂತ ಗೊತ್ತಾಯ್ತಾ? ಸ್ಟ್ರೈನ್ ಎನರ್ಜಿ ಕಾನ್ಸೆಪ್ಟ್. ಅದು ನಾನ್ ನಿಮ್ಗೆ ಡೈರೆಕ್ಟ್ ಆಗಿ ನೆನ್ಪಿಟ್ಕೊಳ್ಳಿ ಅಂತ ಹೇಳ್ಬಿಟ್ಟಿದ್ದೆ ಅನ್ಸುತ್ತೆ ಅಲ್ಲಿ ಅಲ್ವಾ? ಈಕ್ವೇಶನ್ ಡೈರೆಕ್ಟ್ ಆಗಿ ಕೊಟ್ಟಿದ್ದೆ.
ಹೌದು ಸರ್, ಹೌದು ಸರ್.
ಸೊ ದಿಸ್ ಇಸ್ ದ ಕಾನ್ಸೆಪ್ಟ್. ಅರ್ಥ ಆಯ್ತಾ? ಎನಿ ಡೌಟ್ಸ್? ಸಡನ್ ಆಗಿ ಅಪ್ಲೈ ಮಾಡಿದ ತಕ್ಷಣ ಲೋಡ್ ಏನಾಗುತ್ತೆ, ಬ್ರೇಕ್ ಆಗೋಗ್ಬಿಡುತ್ತೆ ಮೆಟೀರಿಯಲ್. ಏನಾಯ್ತು, ಎನರ್ಜಿ ಡಿಸಿಪೇಟ್ ಆಗೋಗ್ಬಿಡ್ತು. ಅದೇ ಗ್ರಾಜುಯಲಿ ಅಪ್ಲೈ ಮಾಡಿದ್ರೆ ಹಾಕ್ತಿವಿ, ತೆಗಿತೀವಿ, ಒರಿಜಿನಲ್ ಬಂತು ಎಲಾಸ್ಟಿಕ್, ಅದಕ್ಕೆ p/a. ಅದು ಇದು 2p/a. ಎರಡೂ ಸೈಡ್ ಟ್ರಯಾಂಗಲ್ ಫಾರ್ಮೇಶನ್ ಆಗೋಗಿದೆ, ರೆಕ್ಟಾಂಗಲ್ ಆಗೋಗ್ಬಿಡ್ತು. ನಿಮ್ಗೆ ಅವನು ಕೆಲವು ಟೈಮ್ ಏನ್ ಮಾಡ್ಬಿಡ್ತಾನೆ ಗೊತ್ತಾ, ಕೆಲವು ಟೈಮ್ ಕ್ವಶನ್ ಹಾಕ್ಬಿಟ್ಟು ಗ್ರಾಜುಯಲಿ ಅಪ್ಲೈಡ್ ಲೋಡ್ ಪಿ ಡೆಲ್ಟಾ ರಿಲೇಶನ್ಶಿಪ್ ಶುಡ್ ಬಿ ಟ್ರಯಾಂಗಲ್, ರೆಕ್ಟಾಂಗಲ್, ಹೆಕ್ಸಾಗಾನ್ ಅಂತ ಎಲ್ಲ ಕೇಳ್ತಾನೆ. ಅವಾಗ ಏನ್ ಮಾಡ್ತೀರಾ? ಗ್ರಾಜುಯಲಿ ಬಂದ್ರೆ ಟ್ರಯಾಂಗಲ್, ಸಡನ್ಲಿ ಬಂದ್ರೆ ರೆಕ್ಟಾಂಗುಲರ್ ಟೈಪ್ ಆಫ್ ಪಿ ಡೆಲ್ಟಾ ಗ್ರಾಫ್. ಗೊತ್ತಾಯ್ತಾ? ಎನಿ ಡೌಟ್ಸ್? This is somewhere important thing. ಸಿ, ಇದೆಲ್ಲ ಬರ್ಕೊಂಡಿದ್ದೀರಲ್ಲ ಆಲ್ರೆಡಿ. ನಿಮ್ ಇದ್ರಲ್ಲೂ ಒಂದ್ ಕಡೆ ಕೊಟ್ಟಿದ್ದೀನಿ. ಆಕ್ಸಿಯಲ್ ಫೋರ್ಸ್, ಬೆಂಡಿಂಗ್, ಶಿಯರ್ ಫೋರ್ಸ್, ಟಾರ್ಷನ್. ಓಕೆ, ನೆಕ್ಸ್ಟ್ ಇಲ್ಲಿ ಪ್ರೂಫ್ ರೆಸಿಲೆನ್ಸ್, modulus of residence, tensile. See, strain energy stored in the body due to tensile or compressive load or resilience. This is same, you know that this resilience, modulus of resilience value is sigma square by 2e, sigma square by 2e. See, I will give 5 minutes break now. So let me move on to MCQ part. Well, before going to 5 minutes break, if you're having any doubts, please ask me now. Afterwards, we will solve with MCQ part. Okay? ಏನ ಡೌಟ್ ಇದ್ರೆ ಕೇಳಿ. ಇಷ್ಟು ಮಾಡಿರೋದ್ರಲ್ಲಿ ನೆಕ್ಸ್ಟ್ MCQ ಮಾಡಕ್ ಹೋಗೋಣ. ಒಂದು 5 ನಿಮಿಷ ಬ್ರೇಕ್ ಕೊಡ್ತೀನಿ. ಎಕ್ಸಾಕ್ಟ್ಲಿ ವಿ ವಿಲ್ ಸ್ಟಾರ್ಟ್ ವಿತ್, ಈಗ ನೀವು ಡಿಸ್ಕಷನ್ ಮುಗಿಸಿ ಆಮೇಲೆ 5 ಮಿನಿಟ್ಸ್ ಟೈಮ್ ಕೊಡ್ತೀನಿ, ಆಮೇಲಿಂದ MCQ ಸ್ಟಾರ್ಟ್ ಮಾಡೋಣ. ಓಕೆ? ಎನಿ ಡೌಟ್ಸ್? ಎಷ್ಟು ಡಿಸ್ಕಷನ್ ಮಾಡಿದೀವಿ ನೋಡಿ. ಇದ್ರ ಜೊತೆಗೆ we also discussed this particular thing. If you are having any doubts, please ask me now. In strain energy, general strain energy ಅಷ್ಟೇ ಆಗಿರೋದು. ಕ್ಯಾಸ್ಟಿಗ್ಲಿಯಾನೋಸ್ ಟಚ್ ಮಾಡಿಲ್ಲ ನಾನು ಇನ್ನು. ಕ್ಯಾಸ್ಟಿಗ್ಲಿಯಾನೋಸ್ ಡಮ್ಮಿ ಲೋಡ್ ಮೆಥಡ್ ಬೇರೆ ಬರುತ್ತೆ ಅದು. Clear? Any doubts? See, ಬರ್ಕೊಂಡಿದ್ದೀರ ತಾನೆ ಇಲ್ಲಿಂದ? ಸ್ಟ್ರೈನ್ ಎನರ್ಜಿ ಅಂದ್ರೆ ಏನು? ಸ್ಟ್ರೈನ್ ಎನರ್ಜಿ ಡ್ಯೂ ಟು ಆಕ್ಸಿಯಲ್ ಫೋರ್ಸಸ್ ಏನಾಗುತ್ತೆ, ಅಂಡ್ ಆಲ್ಸೋ ಸ್ಟ್ರೈನ್ ಎನರ್ಜಿ ಡ್ಯೂ ಟು ಫ್ಲೆಕ್ಚರ್ ಆರ್ ಬೆಂಡಿಂಗ್ ಏನಾಗುತ್ತೆ. This is very, very important thing. AE, where AE is, what is AE? Okay. Well, before going to break, see, ನಿಮ್ಗೆ ಒಂದು ಸಿಂಪಲ್ ಆಗಿ ಒಂದೇ ಒಂದು ಚಿಕ್ಕ ಪ್ರಾಬ್ಲಮ್ ತರ ಒಂದು ಏನೋ ಹೆಂಗ್ ಕಂಪ್ಯೂಟ್ ಮಾಡ್ತೀರಾ ನೋಡೋಣ ಅಂತ. ಓಕೆ, ಸಿ MCQ ಹೋಗ್ಬಿಟ್ರೆ ನಿಮ್ಗೆ ಇದೆಲ್ಲ ಆಮೇಲೆ ಮಿಸ್ಸೇ ಆಗ್ಬಿಡ್ತೀರಾ. ದಿಸ್ ಇಸ್ ಎ ಬಾರ್ ಎಲಿಮೆಂಟ್. ಕ್ಯಾಲ್ಸಿ ಎಲ್ಲ ಇಟ್ಕೊಂಡಿದ್ದೀರಾ ತಾನೆ? This particular bar element is subjected to 4 kilonewton load. 4 kilonewton load. 4 kilonewton load. L is 3 meter. L is 3 meter and area is 20 meter square. Area is 20 meter square and E of the member is 2.1 into 10 raised to the power of 5 MPa. MPa. Okay. Now what is strain energy stored in this member or bar? What is strain energy stored in the bar? Yes, answers. What is the answer? What is the equation for this? This is a bar element. It's not a beam or it is not a truss. It's
F square L by 2A.
It's the equation for single bar element. What is the equation for single bar element?
F square L by 2A.
F square
L by 2A.
L by 2
AE.
AE. What is F?
F4.
What is L?
3.
What is A?
20.
ಒಂದೇ ಒಂದು ಲಾಜಿಕ್ ಇಲ್ಲಿ ಏನ್ ಮಾಡ್ತೀರಾ ನೋಡಿ ನಂಗೆ ಹೇಳಿ. I have given MPa.
Converted into a meter.
But what is the unit? Other units. MPa means Newton per mm square. Yes. But I want it in kilonewton per meter square.
Newton per meter square to MPa.
How much? How to convert that into kilonewton per meter square? See, this is Newton per mm square. ಈ ತರ ಸಿಂಪಲ್ ಆಗಿ ಇಟ್ಬಿಡ್ತಾನೆ. ನೀವ್ ಏನೇನೋ ಹಾಕ್ಬಿಡ್ತೀರಾ. ನ್ಯೂಟನ್ ಪರ್ ಮಿಲಿಮೀಟರ್ ಸ್ಕ್ವೇರ್ ಅಲ್ಲಿ ಇದೆ. ಐ ವಾಂಟ್ ಇಟ್ ಇನ್ ಕಿಲೋ ನ್ಯೂಟನ್ ಪರ್ ಮೀಟರ್ ಸ್ಕ್ವೇರ್.
Divide by 10 raised to 3.
Yes. How much?
100.8.
So this one ಈಗ ಏನ್ ಮಾಡ್ತೀರಪ್ಪ, ನ್ಯೂಟನ್ ಕಿಲೋ ನ್ಯೂಟನ್ ಬೇಕು, ಇದು ಮೀಟರ್ ಸ್ಕ್ವೇರ್ ಬೇಕು, mm ಸ್ಕ್ವೇರ್. ಸೊ ಇವಾಗ ಹೌ ಮಚ್ ಯು ಆರ್ ಗೆಟಿಂಗ್? ಸೊ ಹೌ ಟು ಗೆಟ್ ನ್ಯೂಟನ್ ಟು ಕಿಲೋ ನ್ಯೂಟನ್? ಡಿವೈಡ್ ಮಾಡ್ಬೇಕಾ ಮಲ್ಟಿಪ್ಲೈ ಮಾಡ್ಬೇಕಾ?
9.81 divided.
ಏನ್ ಮಾಡ್ಬೇಕು? 10 ಎಷ್ಟು ಅಂದ್ರೆ 10 ಪಾಯಿಂಟ್. ಕಿಲೋ ಅಂದ್ರೆ ಎಷ್ಟು?
9.8.
10 raised to 3.
10 raised to 3.
10 raised to 3.
Yes, sir.
ಪ್ಲೀಸ್ ಚೆಕ್. ಇಲ್ಲೇ ತಪ್ಪು ಮಾಡೋದು ಹುಡುಗರು ನೀವು. ಇದನ್ನ ಕನ್ವರ್ಟ್ ಕಿಲೋ ನ್ಯೂಟನ್ ಮಾಡ್ಬೇಕು, ಇದನ್ನ ಮೀಟರ್ ಸ್ಕ್ವೇರ್ ಮಾಡ್ಬೇಕು.
Kilo Newton.
See,
sir, it will be multiplied by 10 to the power of 3.
Plus or minus? No, 10 power minus 3 or 10 power plus 3?
10 power plus 3.
1 Newton equal how many kilonewton?
10 to the power of minus 3.
Sir, it's 10 power minus 3.
ಅಲ್ಲಿ ತಪ್ಪು ಮಾಡ್ತೀರಾ, ಅದೇ ಹೇಳ್ತಾ ಇರೋದು 10 power minus 3. ಬಟ್ ಇಲ್ಲಿ ಡಿವೈಡ್ ಬೈ
10 to the power of minus 6.
10 power
minus 6.
ಕರೆಕ್ಟ್ ಆಗಿ ಇಡಿ. ಮೀಟರ್ ಸ್ಕ್ವೇರ್ ಇಂದ
10 power minus 3 ಸ್ಕ್ವೇರ್ ಆಗುತ್ತೆ ಸರ್.
ಮೈನಸ್ 3 ಸ್ಕ್ವೇರ್ ಆಗಿ ಮತ್ತೆ ಮೇಲ್ಗಡೆ ಬರುತ್ತೆ. ಅವಾಗ ಫೈನಲಿ ನಿಮ್ಗೆ ಎಷ್ಟು ಉಳಿಯುತ್ತೆ?
10 to the power of 3.
2100 ಬರುತ್ತೆ. ಬಂತಾ? ಚೆಕ್ ಮಾಡಿ, ಕರೆಕ್ಟ್ ಆಗಿ ಮಾಡಿ. ಬರುತ್ತೆ, ಯಾಕೆ ಬರಲ್ಲ? MPa ನಲ್ಲಿ ಇದೆ, ಕಿಲೋ ನ್ಯೂಟನ್ ಬೇಕು. 2.1 into 10 power 5. 1 Newton. How many kilonewton? 1 Newton or 1 kilonewton equals how many Newton? ಹಿಂಗೆ ಬರ್ಕೊಳ್ರಿ. 1 kilonewton which is equals 10 power 3 newtons. 10 power 3 newtons ಅಲ್ವಾ? ನಿಮ್ಗೆ ಬೇಕಾಗಿರೋದು ನ್ಯೂಟನ್ ಅಲ್ಲಿ ಇದೆ. ನ್ಯೂಟನ್ ಅಲ್ಲಿ ಇದೆ. ಕಿಲೋ ನ್ಯೂಟನ್ ಅಲ್ಲಿ ಬೇಕು ಅಂದ್ರೆ ನ್ಯೂಟನ್ ಈಕ್ವಲ್ 1/.
-3 10 raised to -3
1/10⁻3 1/10⁻3 ಅಂದ್ರೆ ಇಲ್ಲಿ 10⁻3 ಆಯ್ತು. ಸರಿನಾ? ಕಿಲೋ ನ್ಯೂಟನ್ ಬಂತು. ಸರಿನಾ? ಡಿವೈಡೆಡ್ ಬೈ ಹೌ ಟು ಕನ್ವರ್ಟ್ mm² to m². How to convert mm² into m²?
Multiplied by 10 to the power -6.
-6 sir.
ನಿಮಗೆ ಡೌಟ್ ಆಗತ್ತೆ ಅಂದ್ರೆ ಬರ್ಕೊಳ್ರಿ. 1 ಮೀಟರ್ ಈಕ್ವಲ್ ಹೌ ಮೆನಿ ಮಿಲಿಮೀಟರ್?
1000 millimeter.
1000 ಮಿಲಿಮೀಟರ್. ಸರಿನಾ? 1000 ಮಿಲಿಮೀಟರ್. ಸೊ ನಿಮ್ಗೆ ಬೇಕಾಗಿರೋದು ಮೀಟರ್ ಸ್ಕ್ವೇರ್ ಅಲ್ಲಿ. mm² ಅಲ್ಲಿ ಇದೆ, ಅದು ಮೀಟರ್ ಸ್ಕ್ವೇರ್ ಅಲ್ಲಿ ಬೇಕು. ಅಂದ್ರೆ ಇಲ್ಲಿ ಏನಾಗುತ್ತೆ? 10 ಪವರ್ ಏನಾಗುತ್ತೆ ಇಲ್ಲಿ?
-6.
10 ಪವರ್
-6.
-6 ಆ?
So wait.
ಕರೆಕ್ಟ್ ಆಗಿ ಹೇಳ್ಬೇಕು. ಕನ್ವರ್ಟ್ ಮಾಡಿ ಮಿಲಿಮೀಟರ್ ಸ್ಕ್ವೇರ್ ಟು ಮೀಟರ್ ಸ್ಕ್ವೇರ್.
10 raised to -6.
10 power -6.
-6 sir.
10 ಪವರ್ -6.
Yes sir.
ಬಟ್ ಇದು ಮಿಲಿಮೀಟರ್ ಸ್ಕ್ವೇರ್ ಅಲ್ಲಿ ಇದೆ, ನಂಗೆ ಮೀಟರ್ ಸ್ಕ್ವೇರ್ ಅಲ್ಲಿ ಬೇಕಷ್ಟೇ ನಮ್ಗೆ. ಅಂದ್ರೆ ಇಟ್ಸ್ ಆಲ್ರೆಡಿ ಇನ್ ಮಿಲಿಮೀಟರ್ ಸ್ಕ್ವೇರ್. One by 1000 square. 10 power 6.
-6 sir.
ಇವಾಗ ಮಾಡಿ. How much you are getting? Meter square, 10 power 6 minus meter square ಆಯ್ತು. One divided by 1000 ಅಲ್ಲಿ ಬಂದ್ರು. 1 divided by 1000 ಅಷ್ಟೇ ಇದು. ಇನ್ ಮೇಲ್ಗಡೆ ಬಂದ್ರೆ ಏನಾಗುತ್ತೆ? ಎಸ್ ಟೋಟಲ್ ಇದನ್ನ ಡಿಫಾರ್ಮೇಶನ್ ಕಂಪ್ಯೂಟ್ ಮಾಡಿ.
5.7 into 10 raised to -4 sir. .7 into 10 raised to -4 sir.
How much?
5.7 into 10 raised to -4 sir.
So it will become 10 power 6 ಆ ಮೇಲ್ಗಡೆ ಬಂದ್ರೆ. See, check this. This is very, very important. Yes, all of you getting this? 1 by 1000 square alva idu. If you take on the above, it will get 10 power 6. So now substitute the values and tell me what is the strain energy. So sometimes he will give directly AE value. He will give somewhat AE equals say 2.6 into 10 power 6 kilonewton per meter square or kilonewton per square meter, something he will give. Structural rigidity, kilonewton per meter cube, directly he will give, and he is asking to compute this strain energy. Okay. See this conversion, any doubts in this conversion? General they will ask, generally they will ask, because they know student will definitely commit into mistake in this particular part. They will ask MPa, sometimes they will give GPa, gigapascal and all. So any doubts? Okay, I'm not bothering about this answer, but I'm worried about this particular thing. So any doubts? Idu artha aayta ilva idu? ಅರ್ಥ ಆಗಿಲ್ಲ ಅಂದ್ರೆ ಹೇಳ್ತೀನಿ ಮತ್ತೆ. ಏನು ಮಾಡಿಲ್ಲ ರೀ ಇದು. 10⁵ ನ್ಯೂಟನ್ ನ ಕಿಲೋ ನ್ಯೂಟನ್ ಮಾಡಕ್ಕೆ 10⁵ ಇಂದ ಡಿವೈಡ್ ಮಾಡಿದೀನಿ. ಇಲ್ಲಿ ಅದಕ್ಕೆ ಇಲ್ಲಿ ನಿಮಗೆ ಮತ್ತೆ ಬರ್ದೇ ತೋರಿಸಿದೀನಿ ನೋಡಿ. ಅದನ್ನ ಇಲ್ಲಿ ಸಬ್ಸ್ಟಿಟ್ಯೂಟ್ ಮಾಡಿದೀನಿ 1/10⁵ ನ. ಇಲ್ಲಿ 1/1000 ಸ್ಕ್ವೇರ್ ಇದು. ಇಲ್ಲಿ ಬರೀ ನ್ಯೂಟನ್ ಇದೆ, ಅದಕ್ಕೆ ಬರೀ 1 ಟರ್ಮ್ ಬರ್ದೆ. ಸ್ಕ್ವೇರ್ ಇರೋದ್ರಿಂದ ಸ್ಕ್ವೇರ್ ಮಾಡಿದೆ. ಇದು ಇನ್ವರ್ಸ್ ಇರೋದ್ರಿಂದ ಮೇಲ್ ಬಂದ್ರೆ 10⁶ ಆಗುತ್ತೆ. ಎನಿ ಡೌಟ್ಸ್? ಅದರ್ಸ್?
ಸರ್ ಇದು 1 MPa is equal to 1 into 10⁶ Newton per mm square ಆಗುತ್ತಲ್ಲ ಸರ್, ಅವೆಲ್ಲ ಡೈರೆಕ್ಟ್ ಹಾಕಕ್ಕಾಗಲ್ಲ.
MPa ತಗೊಂಡ್ರೆ ನಿಂಗೆ ಏನಾಗುತ್ತೆ ಗೊತ್ತಾ? MPa ನ 10⁶ ನ್ಯೂಟನ್ ಪರ್ mm ಸ್ಕ್ವೇರ್. 1 MPa 1 megapascal 10⁶. MPa ಅಂದ್ರೆ ನ್ಯೂಟನ್ ಪರ್ mm ಸ್ಕ್ವೇರ್.
1 MPa is equal to 1 Newton per mm square.
ಓಕೆ, 1 MPa = 1 ನ್ಯೂಟನ್ ಪರ್ mm ಸ್ಕ್ವೇರ್. ಆಮೇಲೆ ಏನ್ ಮಾಡ್ತೀಯಾ?
ಅಲ್ಲ ಸರ್, ಅವ್ರೇನೋ ಹೇಳಿದ್ರು ನಾನು.
ಆಗಲ್ಲ, ಅದು ಹಂಗೆಲ್ಲ ಆಗಲ್ಲ. ಅವ್ನು ಬರೀ ಪಾಸ್ಕಲ್ ಕೇಳಿದ್ರೆ ಓಕೆ. ಬರೀ ಪಾಸ್ಕಲ್ ಅಂದ್ರೆ ಏನು? ಕಿಲೋಮೀಟರ್ ಪರ್ ಮೀಟರ್ ಸ್ಕ್ವೇರ್, ಡೈರೆಕ್ಟ್ ಅದು.
ಓಕೆ ಓಕೆ ಸರ್.
ಬರೀ ಪಾಸ್ಕಲ್ ಕೇಳಿದ್ರೆ ಡೈರೆಕ್ಟ್ ಅದು ಕಿಲೋಮೀಟರ್ ಪರ್ ಮೀಟರ್ ಸ್ಕ್ವೇರ್. ಅರ್ಥ ಆಯ್ತಾ?
ಓಕೆ ಓಕೆ ಸರ್, ಬಿಡಿ, ಅದು ಕನ್ಫ್ಯೂಸ್ ಆಗಿದೆ.
ಓಕೆ, ಕನ್ಫ್ಯೂಷನ್ ಮಾಡ್ಕೋಬೇಡಿ, ಇದೆಲ್ಲ ತುಂಬಾ ಇಂಪಾರ್ಟೆಂಟ್ ಇದು. ಓಕೆ, now I will give one more problem, and after you just try to solve this problem and try to get the answer. I will give 5 minutes break. Afterwards, exactly at 7:30 or 7:32, we will go through MCQ questions. Okay, now I will give one more small question. Try to solve this question. What is the strain energy stored in the beam? Determine in the beam. Okay, I will give 5 minutes time. Okay, please take a 5 minutes of break, and simultaneously at that time try to solve this problem. Try to solve this problem. I will get back to you exactly at 7:32 or 33.
Sir, what is the value of EI in this?
E value, or you just take this is a rectangle element, so I will give this as a rectangle element. Compute the I value. I will give this as a rectangle element. Cross section I will give as 40 mm to 20 mm. This is rectangle beam. What is the rectangle element I?
It's BD cube by 12.
Compute I. And I will give Young's modulus value as 1.6 into 10⁵ MPa. Okay. Try to solve this problem. Answer. Have you got the answer? See, what is the equation? What is the strain energy equation? What is the strain energy equation for beam? Don't see a section. What is the strain energy equation?
Integration of mx squared divided by 2 times of EI dx.
Mx square divided by 2 EI into dx. Here I. Right? Any doubts? Now, you take this as a C. As per just general like bending moment diagram, take a table. First segment. Next, origin. Next, limit. Next, MX. So what is the first segment? What is the first segment? AC. What is the origin? For AC, you just take here, section. Take this as X. What is the origin? A. What is the limit? A to A, distance is 0. A to C, 2. What is MX? For this, you require reaction. What is the reaction? The symmetric. WL by 2. What is WL by 2? 20 into 4 by 2. Or you take just VA plus VB equals 20. And you take moment at A. 4 VB equal 20. So VB equals how much? 4 VB equals 40. So 10. So because of symmetry, you can easily say that 10 kilonewton, 10 kilonewton. So if you take moment, this is clockwise, left to right. What is the sign convention? Left to right. Positive or negative? Clockwise. Positive. 10 into X. Only that thing. Now, what is the next segment? What is the next segment? BC. Take section here. And take from here, X. What is the origin? B. Limit, once again, 0 to 2. Now, anti-clockwise is, here clockwise is positive, here anti-clockwise is positive, 10x. Now, do the integration. So, U equals integral of first thing, 0 to L, 2, M square. So, 10x whole square into L. L is 2 meter for first member divided by 2 into E value. What is E value? Here, how much E value you are getting? 1.6 into 10 power. How much? 8 8 kilonewton per meter square. I equals BDQ by 12. How much I value? 40 millimeter alva. 40 into D cube. 20 cube by 12. How much you are getting? R. If you want it in meter, directly you take in meter. 40 by 1000. How much? 0.004. 0 point. How much this is? 40 by 1000. 0.04.
0.04, sir.
D cube. 0.02 cube by 12. Directly you are getting in meter cube. Substitute. How much you are getting I? Substitute the I value into dx plus integral of 0 to 2. Once again, 10x whole square into 2 divided by same thing. Or you can do directly 2 times, whatever the value. So what is the integration of 10x square? 10x. So this is 10 into 10 into x square. Clear? X square. What is the integration of x square? X cube by 3. Apply the limits. Finally, you are getting the value. Or sometimes EI is not required. You are getting equation in terms of EI. Okay. So that's why I have given this simple problem. If they give in your MCQ question, such a simple problem is taking 5 to 6 minutes. So that's why these kind of things are not allowed. So be a conclusion that generally what they will ask? They will ask equations, what we discussed in earlier ಅವರ್. ಅರ್ಥ ಆಯ್ತೇನ್ರಿ? ಪ್ರಾಬ್ಲಮ್ ಕೇಳ್ಬಿಟ್ರೆ ನಿಮ್ಗೆ ಮಾಡೋದಕ್ಕೆ ಆಗಲ್ಲ, ಈ ತರದ್ದೆಲ್ಲ ಕೊಡಕ್ ಬರಲ್ಲ ಅವರು. ಅದಕ್ಕೆ ನಿಮ್ಗೆ ಯಾವ ತರ ಕ್ವಶನ್ಸ್ ಕೇಳ್ಬೋದು? ಓನ್ಲಿ ದ ಟೈಪ್ ಆಫ್ ಕ್ವಶನ್ಸ್ ವಾಟ್ ವಿ ಡಿಸ್ಕಸ್ಡ್. Such kind of questions are expected. Clear? Any doubts? Godaita? Okay. Yes. Let me move on to the MCQ part. Later on, we will come back to this particular slide. No problem. If we require few more problems, we will discuss. First, we will try to cover MCQ part. Yes. See the question. A stepped shaft of brass shown in figure is subjected to torque, produces a total angle of twist is 3 degrees. Find the torque on the shaft and strain energy stored in the shaft, and also strain energy stored in the shaft. Yes. First thing, torque. How to compute torque? How to compute torque? What is the torque equation?
It's force multiplied by distance.
Torque. That is bending equation tarane torque equation anta ನಾವು ಡಿಸ್ಕಸ್ ಮಾಡಿದ್ವಲ್ಲ.
Yes, sir. It is the
T by
J g theta by L tau by R.
T by J g theta by L tau by R. This is the torque equation. See, you just observe here. Theta is given 3 degree, right? Angle of twist. And also any other details are given? No, only theta is given. Right? Theta G is also given. G is also given. L is also given. Length, total length is also given. So J, what is J? So if you use this equation, you are getting torque. Now use this equation. T equals G theta J by L. G value is given. Theta is in degree. You have to convert it in radian. How to convert it in radian?
5 by 180.
3 by 180. This is very, very important. Always convert it into radians. Yes, what is the answer? Try to solve. Torque find out ಮಾಡಿ ನಿಮ್ಗೆ ಅಲ್ಲೇ ಗೊತ್ತಾಗೋಗುತ್ತೆ ಯಾವ್ದು ಆನ್ಸರ್ ಅಂತ. ಕೊಟ್ಟಿನಲ್ಲ ಈಕ್ವೇಶನ್. G ವ್ಯಾಲ್ಯೂ ಗೊತ್ತು, ಥೀಟಾ ಗೊತ್ತು, J for circular. What is J equation? Pi d power 4 by what? What is polar modulus?
32.
32 or 64? Yes?
32.
32. Okay. Yes, ಎಷ್ಟು ಬರುತ್ತೆ ನೋಡಿ T value.
Sir,
Yes?
J value.
See here, the thing is you are having two portion,
Yes.
right?
Yes.
For two portion you have to do this. For both the portion you have to do. So G1, G same, theta is also same. So G theta L1. So if you write this, J equals see, this is 3 pi by 180, not 3 by 180. Don't do the mistake. I have written here 3 by 180. This is not 3 by 180. This is 3 pi by 180. When you are converting it to radian. Now for first member. So G is same. 3.85 into 10 power 4. Theta is 3 pi by 180. J, what is J? What is J? J is pi d power 4 by 32. J is pi d power 4. What is the dia for this member? 30 power 4. Try to write here. T equals G value is 3.85 into 10 raised to the power of 4. Theta is 3 pi, 3 degrees there, 3 pi by 180. J, pi d power 4. For first term, that is 30 power 4 by 32 divided by length. Length is in 570 mm. Plus, you do this along with plus, you do one more thing for this member. 3.85 into 10 power 4, 3 degree. That is same 3 pi by 180. And this is also pi into 25 square. 25 for 4 by 32. Divided by length is same 570. Is compute the T value?
Sir, option A.
Yes. We are getting 91,500 Newton millimeter. Please check.
Sir, 91.5 Newton meter.
ನಿಮ್ಗೆ ಇದು ಗೊತ್ತಾದ ತಕ್ಷಣ ಗೊತ್ತಾಗೋಗುತ್ತೆ ಯಾವ್ದು ಆಪ್ಷನ್ ಅಂತ. ಎರಡೇನು ಮಾಡೋ ಅವಶ್ಯಕತೆನೇ ಇರಲ್ಲ. ಬಟ್ ನಿಮ್ಗೆ ಹೇಳ್ಕೊಟ್ಟಿರೋದ್ರಿಂದ you know that the strain energy due to the particular torsion is half into T theta. T value you know that 91500. ಇಲ್ಲ ನಿಮ್ಗೆ ಇದನ್ನ ಎಷ್ಟು ಸ್ಮಾರ್ಟ್ ಆಗಿ ಮಾಡ್ಬೋದು ಅಂದ್ರೆ ಈ ಈಕ್ವೇಶನ್ ಬರ್ಕೊಡಿ. ಈ ಈಕ್ವೇಶನ್ ಬರ್ಕೊಂಬಿಟ್ಟು ನೀವು ಇಲ್ಲಿ ಟಾರ್ಷನ್ ವ್ಯಾಲ್ಯೂ ಈ ವ್ಯಾಲ್ಯೂ ಹಾಕಿದ್ರೆ ಯಾವ್ದಕ್ಕೆ ಈ ವ್ಯಾಲ್ಯೂ ಹಾಕ್ತಿರೋ ಅದು ಆನ್ಸರ್ ಇದು ಬರುತ್ತೆ. ಈ ತರ ಕ್ವಶನ್ ಕೇಳಿದ್ರೆ ಈ ಟಿ ವ್ಯಾಲ್ಯೂ 91500 ಹಾಕಿದ್ರೆ ಥೀಟಾ ನಿಮಗೆ ಗೊತ್ತು. ಹಾಕಿದಾಗ ನಿಮಗೆ ಫಸ್ಟ್ ಆಪ್ಷನ್ ಅಂತ ಗೊತ್ತಾಗೋದು. ಇಲ್ಲಿ ಇರೋದನ್ನೆಲ್ಲ ಟ್ರಯಲ್ ಅಂಡ್ ಎರರ್ ಮೆಥಡ್ ಅಲ್ಲಿ ಸಬ್ಸ್ಟಿಟ್ಯೂಟ್ ಮಾಡ್ತಾ ಹೋಗಿ. ಇದೊಂದು ಈಕ್ವೇಶನ್ ನೆನ್ಪಿಟ್ಕೋಬಹುದು ಅಷ್ಟೇ. ಯು ಈಕ್ವಲ್ ಹಾಫ್ ಇಂಟು ಟಿ ಥೀಟಾ. ಅಲ್ಲಿ ನಿಮ್ಗೆ ಟಿ ವ್ಯಾಲ್ಯೂ ಇದು ಗೊತ್ತು. ಈ ರೈಟ್ ಸೈಡ್ ಕೊಟ್ಟಿರೋದೆಲ್ಲ ಟಿ ವ್ಯಾಲ್ಯೂ. ಟಿ ವ್ಯಾಲ್ಯೂ ನೀವು ಸಬ್ಸ್ಟಿಟ್ಯೂಟ್ ಮಾಡ್ತಾ ಹೋದ್ರೆ ನಿಮ್ಗೆ ಯು ವ್ಯಾಲ್ಯೂ ಸಿಗುತ್ತೆ. ಯಾವ್ದು ಮ್ಯಾಚ್ ಆಗುತ್ತೆ ದಟ್ ಈಸ್ ಯುವರ್ ಆನ್ಸರ್. ಶಾರ್ಟ್ ಕಟ್ ಅದು. ನಾನು ನಿಮ್ಗೆ ಯಾಕೆ ಅಂದ್ರೆ ಹೇಳ್ಕೊಟ್ಟೆ ಅಷ್ಟೇ, ಇದು ಆಸ್ ಪರ್ ಕಾನ್ಸೆಪ್ಟ್. ಬಟ್ MCQ ನಲ್ಲಿ ನಿಮ್ಗೆ ಶಾರ್ಟ್ ಕಟ್ ಯೂಸ್ ಮಾಡ್ಬೇಕು ಜಾಸ್ತಿ. ಈ ಈಕ್ವೇಶನ್ ನೆನ್ಪಿಟ್ಕೊಳ್ಳೋದು ಈಸಿನಾ? Strain energy stored to torque in a bar. This is a bar type of non-prismatic bar element. U equal half into T theta. ಯಾವ್ದಕ್ಕೆ ಇದು ಸಬ್ಸ್ಟಿಟ್ಯೂಟ್ ಮಾಡಿದ್ರೆ ಈ ಆನ್ಸರ್ ಬರ್ತಾ ಇದೆಯಾ? ಚೆಕ್ ಮಾಡಿ. U equal half into 91500 3 pi by 180 ಎಷ್ಟು ಬರುತ್ತೆ ನೋಡಿ. How much you are getting?
Yes, sir, we are getting.
Yes, that's why ಈ ತರ ಸ್ಮಾರ್ಟ್ ವರ್ಕ್ ಮಾಡಿ. ಈ ಈಕ್ವೇಶನ್ ನೆನ್ಪಿಟ್ಕೊಂಬಿಡಿ. ಟಾರ್ಕ್ ಕೇಳಿದ್ನ ಟಾರ್ಕ್ ಅನ್ನು ಸಬ್ಸ್ಟಿಟ್ಯೂಟ್ ಮಾಡಿ ಚೆಕ್ ಮಾಡಿ ಯಾವ್ದು ಆನ್ಸರ್ ಬರುತ್ತೆ ಅದನ್ನ ಟಿಕ್ ಮಾಡ್ಬೇಕು. ಗೊತ್ತಾಯ್ತಾ? ಈ ಸರ್ಕಸ್ ಮಾಡೋದು ನಿಮ್ಗೆ ಕಷ್ಟ. ಈ ಸರ್ಕಸ್ ಅಲ್ಲಿ ನಿಮ್ಗೆ ಯಾವ್ದಾದ್ರು ಒಂದು ಆನ್ಸರ್ ಮಿಸ್ ಆದ್ರೆ ಹೆಚ್ಚು ಕಡಿಮೆ ಯು ಆರ್ ವೇಸ್ಟಿಂಗ್ half an hour.
Sir, one sec. How did you substitute J is equal to pi d power 4 by 32? What is that by 32?
This one. What is mean by J?
Polar moment of
moment of inertia. What is polar moment of inertia?
Ixx plus I by y.
Yes. What is Ixx bd cubic for circular elements of civil engineering?
Pi d power 4 by 64.
Right? By 2, 32. Have you got? J is polar moment of inertia. So for polar moment of inertia, I by, you know that I by y. What is I by y? Z equal I by y. What is Z? Section modulus. Clear? That is polar moment of inertia. What is polar moment of inertia for rectangle? That is also Ixx plus Iyy. BDQ by 12, DBQ by 12. It is called IZ. For J value, Y value, you have to refer your engineering mechanics. Okay. If you want, I will share my textbook soft copy. I have written the textbooks on mechanics of materials as well as engineering mechanics. And also, if you want to learn theoretical concepts of your structures, you can visit my tutorials on YouTube. If you type my name SreeKeshava in YouTube, you are getting more than 100 videos related to civil engineering. Okay. If you want, you are getting whatever your principal stresses, your whatever we discussed, the failure theories and all in that my lecture series. Okay.
Okay, sir.
Clear? If you go to YouTube, put my name, you are getting hundreds videos related to all your structure subject.
SreeKeshava
It's array nodi bedappa SRD saku.
ಇಲ್ಲ ಸರ್ ಅಂದ್ರೆ SreeKeshava ಅಂತ ಎಷ್ಟು ಹೊಡಬೇಕ್ರಿ
ಅಷ್ಟೇ SREEKESHAVA.
ಓಕೆ ಸರ್.
Dr.SreeKeshava ಅಂತ ಯೂಟ್ಯೂಬ್ ಅಲ್ಲಿ ನೋಡಿದ್ರೆ ನಿಮಗೆ ನನ್ನ ಚಾನಲ್ ಸಿಗುತ್ತೆ. ಅದರಲ್ಲಿ ತುಂಬಾ ಪ್ರಾಬ್ಲಮ್ಸ್ ಗಳು ಸಾಲ್ವ್ ಮಾಡಿರ್ತೀನಿ. ನಿಮಗೆ ಮೊಮೆಂಟ್ ಏರಿಯಾ, ಮೊಮೆಂಟ್ ಡಿಸ್ಟ್ರಿಬ್ಯೂಷನ್ ಮೆಥಡ್, ಸ್ಲೋಪ್ ಡಿಫ್ಲೆಕ್ಷನ್ ಮೆಥಡ್ ಎಲ್ಲ ಬರುತ್ತೆ. ಪ್ಲೇ ಲಿಸ್ಟ್ ಹೋದ್ರೆ ಯಾವ ನಿಮ್ಗೆ ಎಂಜಿನಿಯರಿಂಗ್ ಮೆಕ್ಯಾನಿಕ್ಸ್ ಬೇಕು ಅಂದ್ರೆ ಅಲ್ಲಿ ಎಂಜಿನಿಯರಿಂಗ್ ಮೆಕ್ಯಾನಿಕ್ಸ್ ಆತರ ಇರುತ್ತೆ. ನೀವು ಅದನ್ನ ಫಾಲೋ ಮಾಡಿ ಇನ್ ಡೀಟೇಲ್ ಇಫ್ ಯು ವಾಂಟ್. ಓಕೆ. Now this MCQ part, you just follow whatever I am saying. Okay, clear? Yes,
Sir,
we'll move on to next question. Any doubt in this question?
Hello.
It's a very, very important thing. Okay, see.
Hello.
Yes.
Hello.
Helappa.
Civil
Yes.
engineering tutorial by Dr. SreeKeshava.
Yes, that's the thing. Okay.
Okay.
Later we will discuss. First we saw the MCQ. What is the strain energy stored in cantilever beam subjected to point load? Very simple question. Try to solve this. I have shown how to solve all the things. Yes. Any idea?
Option A.
Option A. Others?
Option B, sir, but it is WL
Option
square.
B.
Sir, WL square it should be, sir. It's only W square.
What is the equation? First, what is the equation? U equals integral of mx L dx by
2EI.
2EI. What is mx? W into
X.
x 0 to L. W into x into L dx by 2EI. So if you take W x square by 2, or if you take this particular thing outside, if you take all related terms outside, WL by 2EI, you are getting x square by 2, 0 to L. So L square by 2, W L cube by 4EI. Please check. See, we just take this thing. This is m square mx into dx only. Okay. Please make a correction. Mx into dx. Make a correction. Small correction. There's no L term. Make a correction in beam. M square into dx. So if you do m square into dx, if you take W 2EI outside,
It's option A.
X square by 2. 2 to the how much? 0 to L. W L square by
4EI.
how much?
4E. Sorry, 8EI.
8EI.
Sorry, 4EI. 4EI.
Sir,
here, what is the W into X into for this particular thing? We erase this particular part. Wait. What is the mx value? What is the mx value?
Wx.
Mx value is Wx whole square, right? Mx
Yes.
square, right?
Yes, sir.
Equation. Have you observed the equation? M square by 2ei.
Yes, sir.
M square by 2ei. Have you observed the equation? So you have to identify all those things. Wx square. What we are getting? W square outside. 2ei outside. Here x square. X square will become x cube by
3.
3. 0 to L. So W square
L cube.
L cube divided by
8ei.
6
66ei.
Ti. Which one is the answer?
A1.
A. Please make a note. This is very, very important. We're doing here also we have to do correction, right? Where we made a mistake, Please correct it. Don't do whatever mistake here we did. This is L right, no problem. This is L right. Here, L will not come. Here L will come. Here M square into dx directly. Please make a correction. Correction in your note. Because if you do a mistake here, definitely will do a mistake in all parts. Aside and draw here, this equation only integral of M square into dx by 2ei. It's very, very important. Please correction mark ring. This is M square into dx only. Okay, remaining things are fine, no problem. So any doubts? Any doubts? Okay. We move on to the next question. So clear? This is clear?
Equation for general equations, sir.
General equation is right. M square L. Adik bartade.
Yes.
But beam ge togonak baralla adu. Okay.
Okay, sir.
Next. Here. Frame. Good. Okay. Very good question. What is the strain energy stored in the structure? What is the strain energy stored in the structure? Any guesses? Any guess?
Option D, sir.
D, sir.
See, the thing is clear. U equals integral of M square into dx by 2ei. This is fine. But when you are taking the sections, that is plays a major role. If you take here for this section, XX. So what we are getting? M equals W into X. Right? Finally, if you substitute here, if you apply the limit 0 to A, what we are getting? W square you take outside, by 2ei you take outside. Finally, you are getting like if you are taking W x square. So if you x cube by 3, so limit 0 to A. So you are getting W square A cube by
X square by 2.
What?
X.
Yes. M W x square. X square. What is the integral of x square?
X cube by 3.
X cube by 3. For this part, we are getting W square A cube by 6ei. Next, I am taking this part. For this part, what is the moment here? Here, you are getting a moment. What is moment we are getting? W into A. Here, you are getting W into A for on this body. On this body, moment directly we are getting on column W into A. If you apply the M value to here, so integral of 0 to L. M is WA whole square into dx by 2ei. So what we are getting finally, you take W square outside. So by 2ei outside, you are getting A cube we are getting a square, right? This is a square is also constant. A is also constant, right? A is also constant. It's not x. It's not x. Therefore, w square, a square, you take outside. Here you are getting integral of x. Integral of 1 is x. If you substitute L, how much we are getting? W square, a square, L. This is 0 to L by 2EI. Now add these two things. Total strain energy is this plus this. First one is W square, a cube divided by 6EI plus W square, a square, L by 2EI. Now do the rearrangement. Take the common factor. You take W square, a square outside by 6EI. Also you take outside. Finally, what you are getting here? W a only remaining plus here you are taken 6 outside. Therefore 3. Remaining is 3 and L. Any doubts? This is the U. See, any doubts? Any doubts? See, for this member, vertical member, what I did? I have taken the direct moment. What is the moment? W into A. That is M value. It's very, very important question. Don't do it blindly. Sometimes what happens, see, for an example, now I will give 10 kilonewton. Please do the what is the value of strain energy? 10 kilonewton. If you know the distances, this is 4 meter, 6 meter. For this equation, if you substitute, you are getting the answer. But don't do this. Correct ಮಾಡಿ ಏನು ಬರುತ್ತೆ ನೋಡೋಣ 4 meter 6 meter. ಮತ್ತೆ ಏನು ಮಾಡಬೇಕು ಸೆಗ್ಮೆಂಟ್ ಆ ತರ ಎಲ್ಲ ಹಾಕೊಂಡು ಮಾಡಬೇಕು. This is a frame problem. Strain energy stored in the frame. Last problem is strain energy stored in the beam. Any doubts? Clear? Shall I move on to next question?
Yes, sir.
Okay. Yes. What is the strain energy stored in the member is equal to? Which one?
Option B.
Option B. That is
B.
half into stress into strain into volume. How we got? We know the equation. Any one equation? The equation is given by sigma square by 2E into volume. Right? What is E? E is the ratio of stress over strain. Now, if you take the thing half into, you take sigma square separately. If you take E ratio, it will become inverse E by sigma into volume. Sigma one term get cancelled. What's the remaining thing? Half into stress into strain into volume. Any doubts? ಅರ್ಥ ಆಯ್ತೇನ್ರಿ? So option is B. How we are getting option B? So we know the equation U equal sigma square by 2E into volume. What is E? Young's modulus. Sigma stress by strain. Substitute the values. It will get cancelled. Finally, what's the remaining? Half into stress into strain into volume. Clear? Any doubts?
Yes.
Clear aita? Ena doubt idya?
Sir, clear.
Okay. Next question. Which of the following material is represent stress strain curve for toughest material? Yes, very good question. Very smart and simple question. Which graph?
B.
B. Why? Why B? What is mean by toughness?
Fraction of point.
Here to here. This
Yes,
is the
sir.
deformation. This is the energy for toughness. This is toughness. For this material, you are getting here. For this material, here. For this material, here. So which is the toughest one? B is the toughest one. So any doubts?
No,
so this
sir.
is called toughness. Now, which is the smallest toughest material here?
Yes, sir.
A. Clear? Any doubts? Okay. A 2 meter long bar of uniform section 50 mm square extends 2 mm under limiting axial stress of 200. What is the modulus of resilience of the bar? What is the equation for modulus of resilience? What is
It's
the
tau
equation?
squared by 4 times of G.
Sigma square by
2E.
2E, because it's an axial loading. Which type of loading?
Axial.
Axial. Now stress is known. Have you know the E value? We don't know the E value, right?
No, sir.
How to compute E value? Stress by strain. But we know strain.
Yes,
We know stress.
Yes, sir.
You have to think. Yes, compute E value, compute E value and substitute. Try to get what is the mu value. See, there is simply they have given so many data. Try to get the answer. How much we are getting? Yeshbanto?
100.
Huh?
40.
40. See the units and all. Here, see what is E? E is change in length by original length. Don't substitute 2 meter. 2
Yes,
mm is the change in length. What is the original length? What is original length?
2 meter.
2
See.
meter.
This is a 2 meter.
Sir, it's
bar.
option A, sir.
Try to do this. This is the extended length 2 mm. So what we are getting? 2 meter. So here delta is 2 mm divided by 2000.
Yes.
So how much you are getting? That is E.
0.10 unit.
Yes. If you do this. So any doubts? You have just to substitute the values. Looking ತುಂಬಾ ಕೇರ್ಫುಲ್ ಆಗಿ ಮಾಡ್ರಿ. ಸುಮ್ಮನೆ ಏನೋ ಹಾಕ್ಬಿಡ್ಬೇಡ್ರಿ. E ಅಂದ್ರೆ ಮತ್ತೆ ಇಲ್ಲಿ ನಿಮಗೆ ಎಲ್ಲಾ ಬೇಸಿಕ್ ಇನ್ವಾಲ್ವ್ ಆಗೋಯ್ತಿದ್ರಾಗೆ. E equal change in length by original length ಹಾಕ್ಬೇಕು. Change in length ಕೊಟ್ಟಿದ್ದಾನೆ 2 mm. Original length ನ meters ಅಲ್ಲಿ ಕೊಟ್ಟಿದ್ದಾನೆ. ಅದನ್ನ ಮಿಲಿಮೀಟರ್ ಹಾಕೋಬೇಕು. Yes, any doubts? Others? Shall I move on to next question, or are you having any doubts in this particular question?
No, sir.
Okay. We move on to next question. See, the maximum stress produced in the bar when a load is applied suddenly. Yes, load is applied suddenly. What is the equation? If load is applied suddenly, what is
2
the
times of P by A.
application?
P by A.
P by
2P by A.
P by A for gradual.
Yes, sir.
For sudden, 2P by A.
2P by A.
Yes, compute.
Newton per mm.
The maximum stress produced. Stress is given. Stress sigma is given. Sigma is 40 Newton per mm square. You have to compute. If the same load is applied gradually, If the same load is applied gradually, what is the equation?
P by
P by
A.
A. Then what is the stress produced? Sigma. How much?
Option B.
Others?
Option
20,
B.
sir. Option B.
See, this is very simple. If you compare these two things, P by A get, the thing is eliminated. If P by A get eliminated, if you divide by 2, how much you are getting?
20.
That's all. If you compare these two things, what happened? It will get eliminated. But what is sigma? 40 by 2, how much?
20.
Stay, compare. Take the ratios. If you take the ratios, you are getting the answer. Any doubts? Sigma is given, right? Sigma is given. See, this is very simple. Sigma equal 2P by A. Sigma equal P by A. But this is given. This is given as 40 equal 2P by A. This is not given. So 40 by sigma, which is equal to 2. 2 by 1. P can cancel. Now what is sigma? Sigma equals 40 by 2. How much? 20 MPa or 20 Newton per millimeter square. Clear? Clear? Any doubts?
Yes, sir. Yes, sir.
Okay.
It's clear.
Okay. We move on to the next question. Yes. What is the maximum strain energy stored in a material at its elastic limit per unit volume is known as? Yes. What is the answer? What is this? Maximum strain energy. Material elastic limit. Elastic limit. What is called this?
Resilience.
Not resilience. This is modulus of resilience. Don't confuse, because he's given that limit per unit volume, entire thing. See, I have mentioned also, I think, somewhere in the slide, modulus of resilience. Yes. See, what is modulus of resilience?
The proof resilience for
That's why I have mentioned this proof resilience per unit volume of a material. So what is given? What they have given? Unit volume. Hence, this is called modulus of resilience. Any doubts?
By proof resilience.
Proof resilience. For proof resilience, you just have to try to read the one more sentence I have to given. See, for proof resilience, the proof resilience per unit volume of a material, the proof resilience per unit volume. See, the proof resilience is not a definition of the word. Proof is nothing but it is just like a kind of stress. Not proof resilience means that is not a word. Andre adu modulus of resilience tara alla adu. Andre nimge a sentence alli ನೀವು ಏನು ಅಬ್ಸರ್ವ್ ಮಾಡಬೇಕಂದ್ರೆ, see here y is not given. This is the elastic limit per at a stage of proof resilience only. That's why it's called modulus of resilience. This is not a proof resilience. Proof resilience anta ningilla. ನಿಂಗಿರೋದೇ ರೆಸಿಲೆನ್ಸ್ ಮಾಡ್ಯುಲಸ್ ಆಫ್ ರೆಸಿಲೆನ್ಸ್ ಅಂತ ಟರ್ಮು.
ಓಕೆ ಸರ್.
ಗೊತ್ತಾಯ್ತಾ?
Okay,
ಸೊ
sir.
ಅದರ ಪ್ರೂಫ್ ರೆಸಿಲೆನ್ಸ್ ಅಂತ ನೀನ್ ಹೋಗ್ಲಿ ಅಂತಾನೆ ಹಂಗೆ ಕೊಟ್ಟಿರೋದು ಅವನು. ನೀನ್ ಪ್ರೂಫ್ ರೆಸಿಲೆನ್ಸ್ ಗೆ ಟಿಕ್ ಹಾಕ್ಲಿ ಅಂತಾನೆ ಆಪ್ಷನ್ ಅಂತ ಕೊಟ್ಟಿರೋದು.
ಓಕೆ ಸರ್.
ಆಯ್ತಾ? ನಿಂಗೆ ಯಾವಾಗ ಎಲಾಸ್ಟಿಕ್ ಲಿಮಿಟ್ ಪರ್ ಯೂನಿಟ್ ವಾಲ್ಯೂಮ್ ಅಂತ ಬರ್ತದೋ ಅವಾಗ ದಟ್ ಇಸ್ ಮಾಡ್ಯುಲಸ್ ಆಫ್ ರೆಸಿಲೆನ್ಸ್. ಕ್ಲಿಯರ್?
ಎಸ್ ಸರ್.
Okay. Next question. For the body, a volume V and stress due to gradually applied load. Yes, what is the equation?
Option A, sir.
Option A. Others?
Option A.
Option A. What is the equation?
Sigma square V.
What is the equation for gradually applied load? Sigma equals? What is the equation?
Half into stress into strain into volume.
That is P by A. So directly if you take this, half into sigma square into V. Sigma square into V by 2E. If it is instead of gradual, so that's why you have taken S square V by 2E. If instead of gradual, if I am giving that sudden, on that case,
2P by A.
2P by A. This equation will become?
2 cancelled. Only.
Yes, that is a very, very important. 2P by A, 2 will get cancels. The remaining equation is S square V by E. S square V by E. See, idralli ಎರಡು ಕ್ವೆಶ್ಚನ್ ಸೆಟ್ ಮಾಡಬಹುದು. ಅರ್ಥ ಆಯ್ತಾ? ಎನಿ ಡೌಟ್ಸ್? ಅರ್ಥ ಆಯ್ತಾ ನಮ್ಮ? ಇದು ಹೇಳಿದ್ದು ಈಗ ಸಡನ್ ಅಂತ ಕೊಟ್ರೆ, ಗ್ರಾಜುಯಲಿ ಕೊಟ್ಟಾಗ ಸಿ ನಿಮ್ಗೆ ಈಕ್ವೇಶನ್ P by A, for P by A strain energy remains same. If it is 2P by A, 2 gets cancels, remaining is sigma square V by E. ಇದೆಲ್ಲ ನೋಟ್ ಮಾಡ್ಕೋಬೇಕು ನೀವು. ಎಲ್ಲ ಅಡಿಷನಲ್ ಅದೆಲ್ಲ ನಾನು ಎಲ್ಲಾದ್ನೂ ಸೆಟ್ ಮಾಡ್ತಾ ಇರಕ್ಕಾಗಲ್ಲ. ನಿಮ್ಗೆ ನಾನು ಹೇಳ್ತಾ ಹೋದ್ರೆ ನೀವು ಅದನ್ನ ಕ್ಯಾಚ್ ಮಾಡ್ಬೇಕು. ಎನಿ ಡೌಟ್ಸ್? Any doubts in this question?
No, sir.
No. Okay. Next. Yes. 10th question. An axial load of 100 kilonewton is applied onto bar. Bar ಅಂದ ತಕ್ಷಣ ಯಾವ equation ಬರ್ಬೇಕು ನಿಮ್ ತಲೆಗೆ?
P square into L divided by 2 times of A.
Yes. F square L by 2E or P square L by 2E. Okay. Cross sectional area is given. E is given. Yes. Compute U value. Compute U value. Compute U value. ಕಂಪ್ಯೂಟ್ ಮಾಡಬೇಕು. ಯೂನಿಟ್ ನೋಡ್ಕೊಳ್ಳಿ, ಕಿಲೋ ನ್ಯೂಟನ್. ಅದನ್ನ ನ್ಯೂಟನ್ ಮಾಡ್ತೀರಾ ಅಂದ್ರೆ 100 into 10 power 3 whole square. ಲೆಂತ್ 3 ಮೀಟರ್. ಅದನ್ನ ಮಿಲಿಮೀಟರ್ ಮಾಡ್ತೀರಾ ಅಂದ್ರೆ 3 into 1000, 3000. Area is given, but here A or AE? The equation here.
AE sir.
Yes, ಹೇಳ್ಬೇಕು AE. AE is given 100 mm square, no problem. E is also given kilonewton into 10 power 3 ಮಾಡಿದ್ರೆ ಆಯ್ತು. Yes, try to get the answer.
Oh.
How much? See, you work out
option D.
7.
Option D.
D. All of you getting the same option? Please check the option. Solve ಮಾಡಿ. Check the option. Option D. All of you getting option D? See, ನೀವು ಇಲ್ಲೇ ವರ್ಕ್ ಮಾಡ್ರಿ, ಇಲ್ಲಾಂದ್ರೆ ನಿಮ್ಗೆ ಅರ್ಥ ಆಗಲ್ಲ. Okay? See, if you are getting different answers, please tell me now.
Yeah, option D.
ಸಿ ನಾನು ಏನು ಪ್ರಾಪರ್ ಆಗಿ ಕೊಡ್ತಾ ಇದ್ದೀನಿ, ನೀವು ಪರ್ಫೆಕ್ಟ್ ಆಗಿ ವರ್ಕ್ ಮಾಡ್ಬಿಟ್ಟು ಎಲ್ಲ ನಾನು ಏನ್ ಮಾಡ್ತೀನಿ ಕಾಂಪ್ಲಿಕೇಟ್ ಈಸಿ ತುಂಬಾ ಈಸಿ ಇರೋದೇನು ಹಾಕಕ್ ಹೋಗ್ತಾ ಇಲ್ಲ. ಯಾಕೆಂದ್ರೆ ನೀವು ಪಾಠ ಕೇಳಿದ್ರೆ ಟಿಕ್ ಮಾಡ್ಬಿಡ್ತೀರಾ. ಎಲ್ಲ ಪರ್ಫೆಕ್ಟ್ ಆಗಿ ಮಾಡಿದ್ರೆ ಎಕ್ಸಾಮ್ ನಲ್ಲಿ ಯಾವುದೇ ತರ ಕ್ವಶನ್ ಸೆಟ್ ಮಾಡಿದ್ರು ಯು ಕ್ಯಾನ್ ಅಟೆಂಪ್ಟ್. ಓಕೆ, ಈ ನಿಮ್ಗೆ ಡೌಟ್ ಅಲ್ಲಿ ಅಟೆಂಪ್ಟ್ ಮಾಡೋದಕ್ಕೂ ಸ್ವಲ್ಪ ಗೊತ್ತಿದ್ದ ಅಟೆಂಪ್ಟ್ ಮಾಡೋದಕ್ಕೂ ದೇರ್ಸ್ ಎ ಲಾಟ್ ಆಫ್ ಡಿಫರೆನ್ಸ್. ಓಕೆ, ಬಿಕಾಸ್ ಯು ಆರ್ ಹ್ಯಾವಿಂಗ್ ನೆಗೆಟಿವ್ ಮಾರ್ಕಿಂಗ್. ಸ್ಟ್ರಕ್ಚರ್ಸ್ ವೆರಿ ವೆರಿ ಇಂಪಾರ್ಟೆಂಟ್. ಸೊ ಫಾಸ್ಟ್ ಏನಾರು ಆಗ್ತಾ ಇದೆಯಾ?
ಇಲ್ಲ ಸರ್.
ಸರಿ ಇದೆಯಾ? ಎಲ್ಲರೂ ಕೇಳ್ತಾ ಇರೋದು ನಾನೇ ಕೇಳ್ತಾ ಇದ್ದೀನಿ. ಎನಿ ಕೈಂಡ್ ಆಫ್ ನೀವ್ ಮಾಡ್ತೀರಾ ಸರಿ ಇದೆಯಾ ಇಲ್ಲ ಬೇರೆ ತರ ಏನಾರು ಹೇಳ್ಕೊಡ್ಬೇಕಾ? ನೀವ್ ಹೇಳ್ಬೇಕು. ನೀವು ಆಲ್ರೆಡಿ 1 ವೀಕ್ ಇಸ್ ಓವರ್. ಡೈಲಿ ಕಂಟಿನ್ಯೂಸ್ ಆಗಿ 3 ಅವರ್ಸ್ ಇರುತ್ತೆ. ನನ್ನ ಟೈಮಲ್ಲಿ ನಾನು ಮುಗಿಸ್ಬಿಡ್ತೀನಿ. ಬಟ್ ನೀವು ಫಾಲೋ ಮಾಡ್ತಿದ್ದೀರಾ ತಾನೇ? ಹೇಳದ್ನಲ್ಲ, ಮಾಡ್ತಿದ್ದೀರಾ ಇಲ್ವಾ?
Yes, sir.
ಓಕೆ, ಥ್ಯಾಂಕ್ ಯು. ಓಕೆಪ್ಪ, ಎಸ್ ವಿಲ್ ಮೂವ್ ಆನ್ ಟು ನೆಕ್ಸ್ಟ್ ಕ್ವಶನ್. ಫಾಸ್ಟ್ ಆಗ್ತಾ ಇಲ್ಲ ತಾನೆ?
No, sir.
ಓಕೆ, ನೆಕ್ಸ್ಟ್ ಎ ಪ್ರಿಸ್ಮ್ಯಾಟಿಕ್ ಬಾರ್. ಪ್ರಿಸ್ಮ್ಯಾಟಿಕ್ ಬಾರ್ ಅಂತ ಕೊಟ್ಟ ಅಂದ್ರೆ ಏನ್ ಬರುತ್ತೆ ನಿಮ್ಗೆ? ಸೇಮ್ ಈಕ್ವೇಶನ್. 1 ಮೀಟರ್ ಲಾಂಗ್, 4 ಸ್ಕ್ವೇರ್ ಸೆಂಟಿಮೀಟರ್ ಇನ್ ಏರಿಯಾ. ಸಿ ನಿಮ್ಗೆ ಬಾರ್ ಅಂತ ಬಂದ್ರೆ ಅವನ್ ಏರಿಯಾ ಕೊಟ್ಟೇ ಕೊಡ್ತದೆ. ಅಲ್ಲೇ ನಿಮ್ಗೆ ಗೊತ್ತಾಗೋಗುತ್ತೆ ಅದೇನ್ ಕ್ವಶನ್ ಅಂತ. ಕಂಪ್ರೆಸ್ಡ್ ಆಫ್ ಫೋರ್ಸ್ E, total strain. So what is total strain? What is E value? Total strain alla? Yes, strain energy, not strain. Total strain energy, U value. I just saw here total strain energy.
Sir, it's option B, sir.
Option B, good. Fast, you are too fast. Very good. Yes, others? I think you are getting confidence now. Sir, ಈ ತರ ಕ್ವಶನ್ಸ್ ಕೇಳಿದ್ರೆ ಯೋಚನೆ ಎಲ್ಲ ಮಾಡ್ತೀವಿ ಅಂತ. ಗುಡ್. ಇದೇ ತರ ಎಲ್ಲಾ ಪಾರ್ಟಲ್ಲೂ ಆಗ್ಬೇಕು ನೀವು. ಎಸ್, ಎಫ್ ಸ್ಕ್ವೇರ್ ಫೋರ್ಸ್ 80, ಸೇಮ್ 80 ಸ್ಕ್ವೇರ್. ಲೆಂತ್ in millimeter 1000. 80 square into 1000 divided by 2. A 4 square centimeter ಅಲ್ಲಿದೆ. ಮಿಲಿಮೀಟರ್ ಬೇಕು ಅಂದ್ರೆ 40 ಅಲ್ವಾ? 4 into 10. 1 centimeter equal 10 mm.
10 mm.
40 ಅಷ್ಟೇ. ಅಷ್ಟು ಮಾಡಿದ್ರೆ ನಿಮ್ಗೆ ಬರ್ತದೆ ಆನ್ಸರ್. ಎಷ್ಟು ಬಂತು ಆನ್ಸರ್?
40 kilonewton mm.
ಎಲ್ಲರಿಗೂ ಬಂತಾ?
Yes, sir.
ವೆರಿ ಗುಡ್. 40 kilonewton millimeter. Next, resilience of material is important when it is subjected to. When?
Thermal stresses.
Thermal stresses. Yes, others? Now, I will impose one simple question. Anything we discussed in this chapter regarding thermal stresses?
Shock loading, sir. Answer.
Shock loading.
Yes. Shock loading means sudden loading. Sudden ಆಗಿ ಅಪ್ಲೈ ಮಾಡಿದಾಗ ನಿಮ್ಗೆ ಏನಾಗುತ್ತೆ? What is the equation? Sigma equal 2p by A.
2p by A.
Right? That's why it is very, very important. Resilience. ಗೊತ್ತಾಯ್ತಾ? ನೀವು ಸಡನ್ ಆಗಿ ನೀವು ಒಬ್ಬರೇ ಎಲ್ಲ ಥರ್ಮಲ್ ಸ್ಟ್ರೆಸಸ್ ಅಂತ ಹೇಳೋದು. 90% ಆಫ್ ದಿ ಸ್ಟೂಡೆಂಟ್ಸ್ ದೇ ವಿಲ್ ಗೋ ಫಾರ್ ಆಪ್ಷನ್ 1. ಬಟ್ ಪ್ಲೀಸ್ ಥಿಂಕ್, I have not discussed anything regarding thermal stresses in this particular strain energy concept. Clear? Any doubts? Any doubts? Others? Any other answers? Okay. Yes, then what is the next question? Strain energy stored.
Twice.
Strain energy stored. Strain energy stored in a body due to suddenly applied load compared with when it gradually applied. It already first module alle helidini. What is the answer?
4 times.
4 times.
4 times.
Wow. Yes. How? See, ಕೆಲವು ಟೈಮ್ ಏನಾಗುತ್ತೆ ನಿಮಗೆ strain energy. I am talking about strain energy due to suddenly applied load. What is suddenly applied load?
2P by A.
2P by
A.
A. What is gradually applied load?
P by A.
P by A. What he is asking? The strain energy stored. What is strain energy stored? U equals
Sigma square V by 2E.
sigma square by
2E
into
E.
V. Or in other words, U equals stress into or in general thing you can take like hey someone I don't know
ಚಲೋ ಮುಖ ತಗೋ ಪಟ್ನ
ನೀ ಮುಖ ತೊಳ್ಕೊಳ್ಳು ಅಂತ ನೀನು ಆಫ್ ಮಾಡ್ಕೊ something yes mute okay ha yes 2P by A. What is 2P by A? What is 2P by A? Strain energy. Or you can directly, you just take directly like sigma U gradual. Sigma U gradual is P by A, right? So this is sigma you can take. It is 2 times of sigma because sigma equal P by A. Sigma equal P by A. So P by A will become sigma. 2P by A will become 2 sigma. 2 sigma. What is the ratio is asking? Is the ratio strain energy due to this particular thing? It will become, we know that that is half into sigma square by E into volume, right? So for one thing it will become 2 sigma square, for other it will become sigma square. If you take the ratio, it will become for one, or you can, I will try to simplify this. ಸುಮ್ಮನೆ 4 ಅಂತ ಹಾಕ್ಬಿಡ್ಬೇಡಿ, ನಿಮ್ಗೆ ಅರ್ಥ ಮಾಡ್ಕೊಂಡು ಹಾಕಿ. ಕೆಲವು ಟೈಮ್ ಬರೀ ರೇಷಿಯೋ ಕೇಳಿದಾಗ 2 ಬರುತ್ತೆ. ಸೊ ಇಲ್ಲಿ ನಿಮ್ಗೆ ಹೇಳ್ತೀನಿ, P by A, that is sigma. 2P by A, it will become 2 sigma. So what is the strain energy? Half into stress into
Square.
Stress square into volume, right? Sigma square by 2E. 2E miss aitala. Okay. If you substitute this is for, what is the ratio? Sudden, this is for gradual. For gradual, this is the same equation. For sudden, if you apply this, for sudden, you are what you are getting?
2 extra.
2 sigma square. So for gradual, if you take, you are getting sigma square V by 2E. For sudden, what you are getting? 1 by 2E. 2 sigma square will become 4 sigma square into V. Into V. How much you are getting? 4 sigma square V by 2E. Sarina? Now if you take the ratio, sudden to this is sudden, this is gradual. If you take the ratio, 4 sigma square V divided by sigma square V 2E get cancels. Sigma square will get cancels. How much we are getting? 4. That's why it is 4 times.
ಸರ್ ಎಲ್ಲದನ್ನು ಕಾನ್ಸ್ಟೆಂಟ್ ಅಲ್ಲ ಸರ್, ಲೋಡ್ ಮಾತ್ರ ಡಬಲ್ ಆಗ್ತದೆ
ಅಷ್ಟೇ. ಲೋಡ್ ಮಾತ್ರ ಡಬಲ್ ಆಗುತ್ತೆ. ಬಟ್ ನಿಮ್ಗೆ ಇಲ್ಲಿ ಮೇನ್ ಆಗಿ ಬೇಕಾಗಿರೋದು ಇದು ಸ್ಕ್ವೇರ್ ಆಗತ್ತೆ. ಇಲ್ಲಿ 2 ಸ್ಕ್ವೇರ್ ಆದಾಗ 4 ಆಗುತ್ತೆ ಅಷ್ಟೇ. ಇನ್ನೆಲ್ಲ ಕ್ಯಾನ್ಸಲ್ ಆಗೋಗುತ್ತೆ. ಅದು ಸ್ಕ್ವೇರ್ ಅಲ್ಲಿ P ಸ್ಕ್ವೇರ್ ಆಗತ್ತಲ್ಲ, ಲೋಡ್ ಸ್ಕ್ವೇರ್ ಆಗುತ್ತೆ. 2 ಟೈಮ್ಸ್ ಇದು 4 ಆಗುತ್ತೆ. Clear? Any doubts? Clear? Shall I move on to next question? Yes. What will be the strain energy stored in a metallic bar Try to calculate. Bar ಅಂತ ಕೊಟ್ಟ ತಕ್ಷಣ ನಿಮ್ಗೆ ಏನಾಯ್ತು ಈಕ್ವೇಶನ್ ಏನು?
Square L by 2A.
ಅಷ್ಟೇ. F square L by
2A.
Please
A
try to
is
get the answer. What is force?
A is
Okay, calculate ಮಾಡಿ. 10 kilonewton. 10 into 1000 square. Length in centimeter. Directly take the length. 2 E. E is given.
AE, sir.
Yes, AE. AE. AE is given area. AE. Yes, AE's area is known, right? Because 2 centimeter area of 2 centimeters square missing. 2 centimeters square. 2 centimeters square is area. E is given. Young's model is given a strain. So E equals same sigma by, I think the same type of problem we solved previously. Now once again E sigma is unknown, right? How to calculate E now? Sigma is known or unknown? Sigma equal P by A. Sigma is P by A. P is known. A is known. So this is little bit very good problem. Okay, E equals delta L by original length. So delta L stresses 0.02. Original length is 10. Afterwards, you come back to this equation. So there are several equations we have used, 3 or 4 equations. This is very, very important problem.
Yes,
worthy for 2 marks. All basic concepts we used here. Yes, how much? Try to solve. First, you take E, you don't take E. First compute stress P by A. Next compute strain, change in length by original length. Next compute Young's modulus. It's a ratio of stress over strain.
Sir, option 2.
Option 2. All of you getting option 2? Please check. This is strain energy, U. All of you are getting option 2? I don't know. Please check and confirm me. Okay. ಎಲ್ಲರಿಗೂ ಬಂತಪ್ಪ ಆಪ್ಷನ್ 2 ನೇ? Okay, I'll move on to next question. Is the capacity of strained body for doing work on the removal of straining force is called?
Option 2.
Resilience.
Resilience. Others? Any other answers?
Resilience.
Resilience. What is the definition of resilience? It's the capability of material to absorb energy when it is deformed elastically.
Sorry.
So I am talking about what?
Resilience.
Energy, sir.
Strain energy.
Strained body doing work for removal of straining force.
Resilience.
Yes. Okay, if a graduated tensile load P is applied on an elastic bar axially. So this is an elastic bar. I'm applying axially tensile. Change in length of the bar is X. If it is tends to change, this is X. What will be the strain energy in the material?
Sir, it's option 2.
Option 2.
2, sir. Px by 2.
Yes, others? Any other options?
Option 2.
How we got option 2? What is the strain energy equation?
Half into P into X.
U equal
Half into load into deformation.
half into
Load into
you take
deformation.
like this, then this is P delta. So the strain energy is half into P into delta. So if you take half, P delta is X. So direct one, Px by 2. Yes, next question. Yes, a circular silicon carbide rod. So circular rod exhibiting E value. E value is 450 GPa, gigapascal. So what is gigapascal? How to convert gigapascal to megapascal?
It's 10 to the power of 3
3.
megapascal.
Yes, E equals 450 into 10 power 3 megapascal. 10 power 9 if we are converting into 10 power 6 because here also in MPa. So E converted is under uniaxial stress. Sigma is given. Sigma is 450 MPa. What is the U? What is the U? U. Yes. What is the U? What is the equation? And I don't require answer. What is the equation?
Sigma square by 2E.
Sigma square by 2E into
Here strain energy density.
strain energy density. What is mean by strain energy density? What is energy density?
Per unit volume. It would
Energy per unit volume.
What is the exact term? What is
U
the
by
technical
V.
term?
U by V is equal to sigma square by 2E.
What is that? See, what is this? Mu equal? What is this? Mu. This is energy density. In other words, it's called as resilience. See, he may be asked strain energy density also as modulus of resilience. Both are same. That's why this is very, very important question.
Yes, sir.
He may ask strain energy density or in other words, what is the word?
Resilience.
Resilience or modulus of resilience.
Sir, one doubt.
Yes.
The resilience is strain energy stored in a specimen when it is strained within elastic limit, right?
Yes.
Okay. And the proof resilience is energy stored, maximum energy stored at the elastic limit.
Proof is nothing. Proof anadilla. Proof resilience anta there is no term. Okay. You just keep in your mind that the exact term is modulus of resilience.
Modulus of resilience is
That is
energy per
under
unit
the
volume.
Volume. If you are talking about volume.
Okay.
Clear? What exact your doubt? What is your exact doubt?
No, I wanted the difference between proof resilience and modulus of resilience.
See, modulus of resilience you are getting in under elastic limit.
Okay.
That is clear. Elastic limit is also called it as strain energy density.
Okay.
Okay, but when you are talking about proof resilience,
yes, sir.
There's no proof, which means it's an beyond the elastic limit.
Okay.
So resilience term you don't use in that particular proof.
Okay.
Okay.
Yeah.
Yes. What is the answer?
Sir, it's option 2, sir.
Option
2, sir.
2. Okay. Have you calculated?
Yes, sir.
Yes, sir.
Okay. Others? So clear. So it may be sometime it termed as they may ask like resilience. What is the resilience stored in this specimen? Compute the resilience stored in specimen. Okay. Next. A beam carries UDL throughout its length. In which of the following configuration the strain energy is maximum? Yes. Guess. Okay. Right or wrong? Try to guess. say here cantilever carrying UDL, fixed beam carrying UDL, simply supported beam carrying UDL, propped cantilever carrying UDL. So what is asking? Strain energy, where we are getting Umax. In which type of structure we are getting Umax? If it is cantilever, why? If it is fixed beam, why? If it is simply supported beam, why? If it is propped cantilever, why? Any idea? See, for this you can easily find out the thing. In which type of beam moment is maximum? And moment is minimum. Okay. Say if it is carrying W, what is the moment? W into L, W L square by 2. If for this W L square by 8. For this and this, it is little bit more. It's 16, it's 12, you are getting. If you take for this W L square by 12. For this, you are getting somewhere little bit more. Which one is less? This is M. What is the strain energy equation? U equal integral of M square into dx by
2EI.
2EI. Now you can easily guess M is less. You are getting
cantilever will have maximum.
If you do M square, if you see M, if you divide, if you do this, you are getting which beam is getting maximum strain energy? See, M square into dx by 2EI.
Simply supported.
Simply supported?
Sorry, sorry, cantilever.
Cantilever, why?
Moment is maximum.
Maximum.
Moment is maximum?
That's why strain energy will be maximum.
We are doing integration. We are doing integration. You have to observe the thing like if you substitute like here you are getting full to whatever here you are getting cancel with 2EI and all whatever it may be. When you are doing integration, you are getting higher order. You are getting higher order. For this particular beam, you are getting only x square. X square will become x cube by 3. And if you multiply whatever by 2, you are getting the maximum value. But here you are getting maximum of maximum thing, 12 into that particular value, 8 into that particular value. On that case, the strain energy stored will be maximum under cantilever beam, which is having minimum moment. That particular beam having higher energy. That particular beam having higher energy. Hence, cantilever beam, see, always try to remember this. Moment WL square by 2. For simply supported, WL square by 8. For proper cantilever FEM, WL square by 12, WL square by 12. So ultimately, which is having lesser moment, that particular beam is having ability to take maximum strain energy. That's the important point in this particular section. See, if you getting direct question, don't think too much. Go to cantilever, you are getting right answer. Nothing to worry about that particular part. Okay. Next. What is the next question? A rod of 40 millimeter diameter, 5 meter long is stressed with 47.476 MPa, is subjected to gradual tensile load. Strain energy absorbed by the rod is asking strain energy given modulus of elasticity bar. So which means which equation? What is the equation?
Of sigma E epsilon. Half into strain into stress.
Bar. For bar, what is the equation? F square?
L by 2A.
2AE. Yes, try to get the answer. Here is given stress. So sigma by A. Stress F by A is given stress.
Yes, sir.
So F by A. So for this, which equation is suitable? Sigma square by
2E.
2E into volume. Into volume. L into B into H or D. So length is given, diameter is given. Area is given. If you area is given, na? I'll compute the area. What is the area? Pi d square by 4. So volume will become area into L.
Length.
So you have to think. ನೀವೇ think ಮಾಡಬೇಕು ಈ ತರ ಎಲ್ಲ ಬಂದಾಗ ಯಾವ ತರ you have to get answer ಅಷ್ಟೇ. ಎಲ್ಲ ಬೇಸಿಕ್ ಹಾಕಿ ಆನ್ಸರ್ ತಕ್ಕೋಬೇಕು. Instead of volume, you can take A into L. Yes, try to get the answer.
So 35.40.
35.40. So approximately 35.81. Others? See, today, whatever I am doing purely on strain energy. Tomorrow, we will solving very, very important concept, Castigliano's theorem and dummy load method. We are going to solve all frames, truss, beams. It's a very good topic. So here we are doing only strain energy. And also after this particular strain energy topic, let me move on to very, very important topic. That is your analysis of indeterminate structures, slope deflection method, and moment distribution method. Don't miss the classes. If you are missing the classes, you are losing the marks. Yes. What is the answer? Sigma square. Sigma square. Okay. This is square. By 2E. E is given. 2 into E is given. Unit, no problem. All are in same unit. A, area. Pi d square by 4. Circular rod. That's why. If it is a rectangular, then L into B. If you're computing area, multiply by length. You are getting volume. Yes. It's an easy one. Yes, what is the answer? 35 point. Someone told what is the answer? U equal 35.40. 4 or 5. So more or near value is 35.81. Sometimes hinge ಆಗುತ್ತೆ. ಓ ನಮ್ ಸರ್ ಹೇಳಿದ್ದಾರೆ ಈ ವ್ಯಾಲ್ಯೂ ಇರಲಿಲ್ಲ ಅಂದ್ರೆ ಏನು ಹಾಕಂಗಿಲ್ಲ ಅಂತ ಹಂಗೆ ಬಂದ್ಬಿಟ್ಟಿರ. ನಿಯರ್ ಬೈ ವ್ಯಾಲ್ಯೂಸ್ ಇದ್ರೆ ಹಾಕ್ಬೇಕು. ಗೊತ್ತಾಯ್ತಂಡ್ರೋ? ಗ್ರೇಸ್ ಕೊಡಲ್ಲ. ಗೊತ್ತಾಯ್ತಾ? 35.5 ಬಂದಿದೆ, ಇಲ್ಲ 4 ಬರುತ್ತೆ, ಇಲ್ಲ ಸಮ್ಟೈಮ್ 2 ಬರುತ್ತೆ, ಅಲ್ಲಿ 8 9 ಇರುತ್ತೆ. ಓ ಅದಿಲ್ಲ ವ್ಯಾಲ್ಯೂಸ್ ಗ್ರೇಸ್ ಅಂತ ಹಂಗೆ ಆಗ್ತದೆ ಬಂದ್ಬಿಟ್ಟಿರ ಆಮೇಲೆ. ಓಕೆ, ಅಟೆಂಪ್ಟ್ ಮಾಡ್ಬೇಕು ಅದೆಲ್ಲ. ಎಸ್, ನೆಕ್ಸ್ಟ್ ಫಾರ್ ದಿಸ್ ಕ್ವಶನ್. ವಾಟ್ ಇಸ್ ದ ಆನ್ಸರ್? ನಾನು ಲಾಸ್ಟ್ ಅಲ್ಲಿ ಈ ತರ ಫ್ರೇಮಿಂಗ್ ಮಾಡಿದ್ದೆ ಅಲ್ವಾ? ಈ ತರ ಫ್ರೇಮಿಂಗ್ ಮಾಡಿದ್ವಿ ಅಲ್ವಾ? Now it's a ulta one. What is the answer? A frame is subjected to P. The frame has a constant flexural rigidity EI. The effect of axial load is neglected. The deflection at point A due to applied load is? Yes, what is the answer? Try to guess. ಇಷ್ಟೆಲ್ಲ ಮಾಡಿದೀವಿ, ಒಂದು ಸಣ್ಣ ಗೆಸ್ ಮಾಡ್ರಿ.
Sir, 4PL cube by 3A.
4PL cube by 3EI. Others? Any other answers? Guesses? ಗೆಸ್ ಮಾಡಿ ನೋಡೋಣ ಎಷ್ಟು ಯಾವ ತರ ಗೆಸ್ ಮಾಡಿದ್ರೆ ಏನು, ಒಂಚೂರು ಐಡಿಯಾ ಇಟ್ಕೊಂಡು ಗೆಸ್ ಮಾಡಿ, ಸರಿ ಆಗುತ್ತೆ. ಪ್ರೀವಿಯಸ್ ನಾನು ಬರ್ದೀನಿ ಆ ತರ ಫ್ರೇಮ್ ನಾವು ಸಾಲ್ವ್ ಮಾಡಿದೀವಿ. It's a reverse one. So it's asking deflection at this particular point. Others, ಒಂದಿಬ್ರಾರು ಗೆಸ್ ಮಾಡ್ರು, ಯಾರ್ದಾರು ಸೇಮ್ ಸಿಮಿಲರ್ ಆನ್ಸರ್ಸ್ ಬರುತ್ತಾ? Yes, take it as homework. I don't tell the answer because it's a similar kind of question. I think one who guessed it may be right.
Yes, sir. Sir, horizontal will be having P into X
Yes.
for this, and vertical will have P into L.
Yes.
So total strain energy is integration m square dx by 2a plus m square dx by 2a.
Very good.
We'll substitute px whole square dx by 2a plus pl whole square by 2a,
Right.
which is equated to the of p delta.
Sir, I got option 4, sir.
4.
So that
Yes.
will be 4PL cube by 3.
That is right. You have to substitute in frame. You are getting the answer 4PL cube by 3i. Or just check. No problem. I am giving as optional. Don't go for this particular thing. If you are getting the others, you just discuss in next class. No problem. Okay. We'll move on to the, I think, last question. We are having one more question. Yes. I think these kind of problems are generally they will ask. Yes. Any guesses? Any guesses? It's similar kind, but you have to work out. Any guesses? So ಇದನ್ನೆಲ್ಲ ವರ್ಕೌಟ್ ಮಾಡ್ತಾ ಕೂತ್ಕೋಬೇಡಿ, ಇದನ್ನೆಲ್ಲ ಬರ್ಕೊಂಬಿಡಿ, ಸ್ಟ್ರೈಟ್ ಆಗಿ ಹೋಗ್ಬೇಕು. ಇದನ್ನೆಲ್ಲ ವರ್ಕೌಟ್ ಮಾಡಿದ್ರೆ ಯು ಆರ್ ಲೂಸಿಂಗ್ ಯುವರ್ ಟೈಮ್. These are all standard cases in frames, whatever I have given here. Yes, try to guess the answer. It's also same thing, but here W, L by 2 all are the given. If you substitute whatever the value, whatever I have given, we've obtained the equation, you are getting strain energy. Yes, any guesses? Strain energy. What is the strain energy in the given frame? Any guesses? So the case, so some cases ನೋಡಿ ಇದನ್ನು ನೆನಪಿಟ್ಕೊಳ್ಳಿ. Instead of UDL, they may give, instead of point load, they may give like UDL, and also they may give QL as well as L. So on this case, you have to take what is the axial deformation. So on this case, you are getting U equals 48L. So you have to just try to remember these things. Yes, any guesses? So please remember, this is the answer for you for this kind. You are getting 7 WL cubed divided by 24 EI. Remember, try to remember this. Okay, idnella workout madak hobedi. Idu amele e question, this is right. Whatever you have told, it's right. 4PL cubed divided by 3EI. ಇದೆಲ್ಲ ಒಂದ್ ಕಡೆ ಬರ್ದಿಟ್ಕೊಡಿ. ಇದನ್ನೆಲ್ಲ ವರ್ಕೌಟ್ ಮಾಡ್ತಾ ಇದ್ರೆ ಆಗಲ್ಲ, ಟೈಮ್ ಸಾಕಾಗಲ್ಲ. ನೆನ್ನೆ SFD BMD ಮಾಡಿದ್ವಲ್ಲ ಆ ತರ ಆಗುತ್ತೆ. So don't waste your time. Just try to memorize these type of questions. Okay. I think yes, this is the last one. Strain energy stored in uniform bar. ಏನಪ್ಪಾ? Uniform bar. U equals sigma square L by 2AE. Which option is right?
It's option D.
Option D. So what in option D? Sigma square AL by 2E. If you multiply and divide by A 2E, how it goes to A denominator? Any other answers? See, I think if we use pi square, then this is the answer. Sigma square L by 2AE. Or any other answers?
Sir, it's option D, sir.
D.
Yes, sir.
What is the
Option.
equation? What is the equation?
Sir, what I did is, first of all, half into stress into strain into volume, right?
Oh, yes. U
Sir,
equals half into
stress into
strain into volume.
Volume. Yeah. So
Yes.
strain is stress divided by Young's modulus of elasticity.
Right. Sigma into sigma by E by 2 into volume.
Volume is nothing but A into L.
Yes, A into L.
Yeah.
So you are getting sigma square AL by 2E. Right. Very good. So
Yes,
this
sir.
way you have to think. So if we write direct thing, we are not getting. So we have to think in a way that half into sigma into stress into strain into volume is the basic strain energy equation. So it's a general thing, but we have to guess the answers in accurate way. Okay, we move on to last question. It's very good. What is the last question? What is modulus of resonance?
It's a resonance per unit volume.
Resonance per unit volume. Yes, any other answers? What is modulus of resonance? Modulus of resonance. I've given sentence.
Sir, it's option C.
C. Proof resonance to unit volume. Proof resonance to unit volume or check. Finally, I will put remark check. Check yourself and get the answer, because it's already we are given in statement form. Okay. Thank you. Any doubts? So we discussed so many things with respect to strain energy in detail. and also we spent more and more time on this topic. Tomorrow, we move on to the very, very important topic, Castigliano's theorem. I hope you are able to solve a basic related to strain energy. Thank you.
Thank you, sir.